Welcome to this Roblox game development series. Together, we're going to learn how to create Roblox games. First thing first, you need to get Roblox Studio. And second of all, you need to get this Roblox Bible document, which will be down below in the description. It will be completely free. Save the link as I will be updating this. This is going to be like a live book that will get updated every single week, every single month with new tutorials and guides. So today we're going to cover the Roblox Studio basics. First of all, install the software. I drop a link here for how to download it. And then the next thing after we install it is we want to open up a template. A good enough template is baseplate for now, because we're going to learn the basic functions of Roblox Studio. The learning method for this kind of tutorials is active participation. Everything you see, you want to replicate on your own device, so you can really start using your brain with the things you learn, so they stick into your memory. So the first thing is navigation controls. This place is the viewport, which is essentially where your world will be, your map will be. This is essentially the 3D elements of your game. So how do you navigate this? First, left click, so you're in this window. And then what you can do is use W, S, A, and D to move around. By using Q and T, you can go up and down the map, as you can see here, super easily. So you can couple these controls to move anywhere you need as fast as possible. Also, by right click plus dragging your mouse around, you can, move like that. So you can pretty much use that to change where the camera looks at, which is also very powerful. Now about the scroll wheel, you zoom in and you zoom out. And this is very effective if you want to move from places very, very fast. Boom, you see how far away I got from that? Look how fast I'm going to come back to this spawn location. So these are the basic controls on how to navigate this space. Then we want to move forward and understand a little bit about the windows. We got the Explorer window, which is essentially where all our assets for our game will reside, all our scripts, all our characters, even this view, which is essentially the workspace. This is essentially your map. And if you click on this drag down button, you can see the elements inside the workspace, similarly on lighting and pretty much with any other of these hierarchical options. So again, this is the file directory of your game. Now, if you click, for example, on any of these parts that are inside, for example, the workspace, like spawn location, you're going to see the properties panel. This is essentially a configuration panel that shows you the different attributes and options for a selected item, a selected block, object, whatever you want to call it. So for example, we have here the base plate, which is essentially the ground on the map. We can see different options like brick color. We can click that and change it, and we can see the change reflect on the map, which can change its color, for example, to red, or its material, from plastic to leather or to metal, whatever you want, whatever you need. And you can see here the changes are pretty significant. You also have other options that you would need for specific assets. For example, locked means that this item will not move at all, no matter what. You can set the size in each of the XYZ dimensions. You can set collisions, whether this item can be hit or can be touched, and a lot of other stuff that we're going to cover in future tutorials. Also, we've got this dashboard style that has a lot of different options. Right now we're at home, but we also have the option for avatars, where we can change how our 3D characters work, set animations, and do a lot of other things. We got the UI that allows us to create menus and buttons. We got scripts, which is specifically for scripting, finding stuff on different scripts. Model, which is essentially anything you need to do on 3D models. And finally, plugins, which are very helpful in specific functions of your development to speed it up and make it easier. So workspace. So I want to tell you a little bit more things about the Explorer. Workspace has like one of the most important folders, which is where everything is happening. It's essentially the 3D world rendered to the players. Then you also have parent and child relationships. Keep it in mind. Here, the workspace is the parent of base plate, spawn location, terrain, camera. And the kids of workspace is the camera, the terrain, spawn location, base plate. So there is this kind of analogy, this kind of interplay between the hierarchy of this explorer structure. So let's go and let's do some building. So we want to go to the models tab, or we could use the home tab, doesn't really matter at this point. Let's go to model and create a new part by clicking on the part button. We can see our part here, and one useful trick is because your workspace is going to be very complicated, you can select a part that you want to see and click the F button to zoom to it. In some cases it works, in other cases it doesn't work, but yeah, here you go. If you forget the button, right click on a part and you're going to see the zoom to option as F. This is very, very helpful. So here we can see that we have like a 3D block, a 3D part, that's how it's called. So we got a little bit of different options we will see on home and also on the model, the avatar. These are pretty stable, and it is the select tool, the move tool, the scale tool, the rotate tool, and the transform tool. Now these are very interesting tools, and we're going to see what each one of these does. So first of all, we got the select, which essentially allows you to select an element and you can move it around. As you can see, this element is like snatching on the grid here on the base plate. So it's not moving away up and down, it's just moving on top of the surface. We got the move tool, so let's select this element and it opens up the three axes, X, Y, and Z. So you can move across specific directions your element without changing the other directions. This is very, very helpful. We got the scale tool that allows us to scale a model across different dimensions. In most cases, and for most parts, you will only change one dimension at a time, but if you've got a specific function, it's going to uniformly do just that. So boom, I just made it bigger. We got the rotate tool that again allows us to rotate an object across specific dimensions. So for example, you could do something like that and boom. I don't know, maybe you want to do this for some kind of strange design or whatever, but this is also a powerful tool. And we also have this transform tool that I've never used and probably will just never use. But you can play around with it, doesn't really hurt. At the end of the day, if you make something you don't like, you can just press delete. So finally, how can we save our progress? You're going to go to File and you can then go ahead and save to file as. This will allow you to create a file to store on your computer and you can load or send to other people. However, if you want to continue developing something on your system, you can essentially publish this to the cloud. You can publish this to the Roblox servers. Even though it will be still private, you won't have to hold it on your system. And what you want to do is publish to Roblox. This is at least what I suggest. So what we're going to call this game is still a brain rot. Even though we're not making still a brain rot right now, I'm just going to call that. Click create and essentially your map and your game will get uploaded on your Roblox server, on your Roblox storage that is associated with your Roblox account. So this is, the tutorial for the initial beginning of Roblox Studio. I will give you some objectives. First of all, I want you to create different kind of parts, which you can find. I don't want to spoil it, but if you click on this button, you will see the different kind of parts. Try to create them. Manipulate it with scale tool, rotate tool, move tool, just to see what happens. Also play around a little bit with the properties tab. For example, if I select this and go ahead, I can change its color to red, as you can obviously see. So play around with these settings to understand what each one of these does to your blocks. And make sure to save your place or your game to Roblox. And before you leave your game, always press Ctrl S to save it, so you don't lose your progress. In today's tutorial, we're going to learn how we can begin scripting inside Roblox. First thing first, I want to let you know that I've also updated the Roblox Bible for development. It's going to be down below in the link in the description, completely free for you to check out. I added the section of Roblox scripting and type of scripts, which is what we're going to cover today. So let's begin. First of all, you want to open up Roblox Studio. And before we begin coding anything, I want to give you an understanding of what scripting is. As we can see here, we see a 3D world, we see buildings, and essentially building allows us to build on top of this world, the 3D world, but scripting provides the logic. For example, you might see this red thing that is stable here. We could make this through scripting, start flying or going around and around just using code. Scripting is essentially coding. So the tool that allows us to do this is called the script, and it's a document that contains code and instructions, and the language used is Lua for Roblox, that is based on an adaptations of Lua, a programming language usually used on gaming mods. So let's begin by creating our first script. We're going to place it in the workspace. Usually scripts are either in the workspace, replicate storage, or server script service. So let's go ahead and click the plus sign button and click script. You can also search for script by typing script. And as you can see here, there are 3 different kinds of scripts. You got module script, local script, and script. I don't want to complicate it for you right now. At the end of today's video, I'm going to explain what each one of these options means. But for our own use case right now, we're going to focus on this script. If you let your mouse hover over, it tells you that it runs Luau code on the server. So this is a server script. So let's click that and boom, we can see here that the code is initialized with hello world. And we see print here. So what print is going to do is it going to show a message on our output window, which I have open over here, and I will show you how to open it. It will say here hello world when we start the game, when we start to play the game. So how can you get this output window open? Well, you go to the view tab over here on the menu upside down, and you go to the window tab and select output, and the output window will open up on the bottom side. So let's go ahead and play the game. We click this button that says play and we begin playing our game. This is literally like playing a Roblox game. You can navigate the world with your character. Look at my avatar here, so beautiful. Really swag, really a lot of aura. So you can move around, but we don't want to move around right now. What we want to see is whether we see the hello world message. And as we can see, if we go to the output window, we see hello world. We also see that this is a server script, so this message comes from the server, and we can see the exact script along with its location. If we click on it, the script will open up. Great, right? So we can actually see which script wrote that message, and it's very powerful. Print messages are very powerful to understand what's running and what's not running, and it allows you to understand which part of your code is okay and which part of your code may be not okay. If you write a print and you don't see it, well, something's not running. So print statement is very powerful to find errors. Keep it in mind. So how can you write a print message? First, we got the print command, 2 parentheses. Each parenthesis should open and close, and the message that we want to see is inside the quotation marks. So let's say that we delete this by just doing backspace. Let's also stop the game, because when you test the game, if you don't stop it, any change you do will be reverted. So you always want to make changes when the game is not getting played. So always stop the simulation before you do changes. So let's write a new print message. You write print, open and close parentheses, quotation marks. Both quotation marks should open and close. Open means you write one quotation mark and then you follow it with another one and write hello arrow. Okay, so like that message. Now, very important, you don't want to write something like that. This doesn't work. This also doesn't work. Something like this also is not working. I want you to understand why each one of these doesn't work. I will give you 1 second to pause the video, think about it, and then I will tell you the answer. So, first one doesn't have parentheses. You need to open the parentheses and then put your message with quote marks inside. Second one doesn't have quote marks, so it's not going to work. However, in the future, we're going to see that you can do something like that, where you define a variable like that, and then put it inside print. But this is for the future. And here, you don't close the quotation mark, and you don't close the parentheses. To fix it, close quotation mark, close parentheses, should work. Let's play the game to see if this actually works. We click play, and we see the message, hello XXX. Great job. We stop the game, and we go ahead and make a mistake. Let's play the game. Whoa, we just got an error. It's not the end of the world. It says malformed string. String is essentially anything that has quote marks. And it says, do you forget to finish it? Well, probably yes. So this is a very simple example of how you script. In our case, we do a simple server script inside the workspace, at least for now. We're going to make more complicated scripts as the tutorials move forward. So before we go a little bit deeper into what kind of scripts exist, first thing is your objective for next time. I want you to create a workspace script and write 3 different print messages. I want you also to make mistakes and see what went wrong and try to fix it. And also, if you want to zoom in here, because code might be small, you can do Control plus sign or Control and scroll with your mouse inside or outside. So scroll towards the script with your mouse to zoom, or outwards towards yourself if you want to zoom out. So let's go ahead and see the types of scripts. So we got 3 types of scripts. This is a server script, what we just wrote, it's called just script, and we usually place this into server script service. This runs on the server. Anything you want to verify that is crucial, you won't run on the server. Players cannot see the code, so they cannot hack it. A local script is a client script. This is what runs on the computer, phone console of the player. For example, it shows like if a player clicks C to open a door, it handles that. It can display GUI to the players, capture movement of the players, visual effects, and this is good to go. But anything that is done on that script, only the player sees, other players don't see. And finally, we have the module script, which we usually place in the replicated storage. These scripts essentially use scripts from other libraries. They're replicated both on the server and the client, so both the player and the server sees them. And it's usually to do helpful stuff between the server and the client. The lines are quite blurry, and these are called module scripts. So here I got also a table to show you the differences between each of these. And also, final critical note, local scripts, which are client-based, don't run on server script service, so don't place them there. So if we write script, we can see the 3 different types of script. Local script for the client, server script as script, and module script that is replicated across both client and server. Okay, so you can also see they have different namings and different icons, so you can easily understand what is what. It will take a little bit of time to get used to that, but keep that in mind, there is this separation. Let me also help you a little bit by showing you the 3 different kinds of scripts. I'll just place the icon here. And of course, this document will be available completely for free in the description for you to check out. Save the link because this is going to get massively updated in the next few weeks and few months. Welcome to another Roblox Studio tutorial. Today we're going to focus again on scripting. This tutorial builds exactly on top of the previous one. And today you are going to learn all about data types and how to store values inside what we call encoding variables. Let's begin. But before we begin, I want to let you know that down below in the description, you are going to find the link for the Roblox Bible, which is where you will save this document into your browser, and every single month you are going to get new information about Roblox game development. This is going to be super powerful here. This is literally a free book that you can use as your guide while you learn to code and create stuff in Roblox Studio. So let's begin with the fundamental data types. So the most simple data type is a Boolean. This means it's a true or false. You can save something as true or false. So go ahead and open up your script that you created in the previous tutorial. If you don't have a script, go to your workspace, +, script, and here you can type print, which we covered previously, and you have 2 types of things you can type for Booleans: print true, print false. So for a Boolean, how you capture it and denote it is by typing true or false. Now it's very important that this is in lowercase. All right, so make sure that it's in lowercase, and this is how you can say whether that's true or false. And a simple example of where this can be used is that if you go on the workspace, for example, the base plate, you can see here that it has some properties by opening up the properties tab. For example, you see here Casado, and we see the checkbox like clicked. This means that the attribute or a variable that is said cast shadow equals to true. If you click that, then it's not selected and it equals to false. So this is what is happening underneath. What you see here is our appearance. Essentially, the value of the checkbox is either true or false, and this is how it's saved into the code. If you run the game, you are going to see a print message that says true and says false. All right, so that's the booleans. Very useful. You're going to probably use them so many times, and you are going to see exactly what happens with these in the future when we make more complicated scripts. The next one is numbers. So you got numbers 10, you got like negative numbers that you put a minus in front, and then you got numbers that are decimals, 10.5, and the decimal is done through the point. All right, so these are numbers. You can have integers, which is the 10 and minus 10. You have floats or decimals like this one, and you can print them to see them out. So usually you use these for damages, or for example here you see reflectiveness. So this property can be either an integer or at 0, 1 or get decimal values. Underneath, what is saved is literally something like that. So it's the numbers data type. Good enough? Good enough. Hopefully you understand all about data types. I'm trying not to waste a lot of time on this because this is really, elementary school logic and math. These things are very simple to understand if you just know English and if you live in the western part of the world. It's just numbers and conditions, true or false. And finally, what we have used in the previous tutorials is what we call strings. And this is essentially text. Strings means a sequence of characters. So a string is like this one that says hello, Iro. So why do we call them a string? Because it's a sequence of characters. It's just how it's called. You can refer to it as text, doesn't really matter. But for strings, we need to have a special type of showing them to code. And programmatically, strings are usually captured inside these quote marks. You need an opening quote mark and a closing quote mark. You can go with single quote marks or double quote marks, doesn't really matter. But you cannot combine double quote marks with single quote marks. That's really not working. You pick one of the two. So either you open a string with a double quote mark and close it with a double quote mark, or you do it with a single quote mark. And inside, you can have text, you can have numbers, but this is handled as text. All of this is handled as text. So if I take this, Control X, move it here, it's going to be seen as string. This is not a number anymore. It's just a sequence of characters. It's just text because it's inside the quote marks. All right, so this is string, this is text. And you could easily see it in properties like brick color here is a case of text. Name here that is base placed is also a type of text. And there are so many other places where we use text, like for example default here. In some cases these things, because they have pre-denoted values, can be called somewhere something like enumerations, but this is a case for something else. But in general, all of these things at their core are text. So you can see also where you can use text, for example, material glass. You could, for example, create a tag or whatever, or an attribute, which is essentially a new variable. And again, here you see the different types. So you got like string, you got Boolean, you got number, you got some other more complicated stuff that are basically Roblox related. We're not going to cover them here because these are more complicated structures that are not really data types. But yeah, these are the three basic data types: Boolean, number, and string. And I got them all in the Roblox Bible in a summary table along with their descriptions. It's a little bit complicated at first to really understand them, but trust me, if you do the objectives for today's video, which is opening up your script and trying to play around with them, trying to print them out, you are going to understand them. Okay, so just go ahead and do these three tasks and you are going to be a master of data types in just literally 7 minutes of this tutorial. So now let's move to variables. This also is part of the Bible, the Roblox Bible. So let's begin. Let's check that out. So as your game grows, you will need multiple scripts. And it's important that inside scripts, you store information in what we call variables. So it's very, very important to understand what variables hold. As I've told you before, here, all of these things you see on the left-hand side of the properties like brick color, cast shadow, color, is variables, and each variable holds specific data inside. For example, material holds grass string inside of it. Reflectance is holding a data type of, let's say, int, decimal, and number. Okay, and these are essentially variables that hold informations. So in our scripts, how can we actually write a variable? What we do is very, very simple. We go here and we type local, all right? We specify the name of the variable. I will say just my var, and then we can write what value we want the variable to store, for example, 0. And we can then go ahead and print our variable. Now someone will ask, why aren't you printing my var like that? So let me show you the difference. And I'm going to explain it to you, but it's not really easily understandable by people, but this is just how code works. So we see two different messages. We see a 0 and a my var. Wait a minute. Why is this the first line on line 12? Why is it printing 0 and not my var? And why the second one is printing my var and not 0? Like, what is going on here? So what you gotta understand is that here on the first command, we're printing the value of the variable. So when I put my var here, my var is essentially a way to say 0. So on print here, we're printing 0. While here, we're printing a string because we have the double quotation marks, remember, from just a couple of minutes before? So we're printing here the my variable string, the text essentially. But here we're printing the value of the variable that is called my var. You can see how powerful this is, right? And essentially how this 0 value is stored inside my var is through this assignment operator. Okay, so what we say here is that our variable is like existing only in the scripts. That's why it's called local. It's only relevant inside the script. If you go and create another script and try to access the value of my var, it's not gonna exist. So my var equals 0. So I store the value of 0 in my var, only in this file, only in the script. And then I say print the value of my var. The code goes ahead, it's 0, and returns 0 to us. So that's the value of 0. Hopefully you got that. If you didn't get that, play around with it. Try it out. Fail a couple of times. And a lot of people ask, why use variables? It helps us prevent repetitive coding. For example, if I want to print 5, 6, 7 times the value of 0, I can just store it in a variable and then just print its value again. Let's check it out. Boom, 0, 0, 0, 0, 0. Pretty great. Now, question, what is going to happen? I want you to think about it. If after the first prints, I change the value of my var to 1. Let's check it out. Initially, on the first 3 prints, it's going to be 0, and then it's going to become 1. That's really lovely, to be honest with you. This is really, really powerful. So we change the value of my var halfway to 1, and then the new value is used. Amazing, right? So we did the change once, and then the value is updated for all of these cases. Now, some conventions. The first word is lowercase. So you begin with lowercase. And the next word in the naming is going to begin with capital. For example, if we want to create player health, we do it like that. Player health 100. If we want to say, for example, total score amount, we do it like that. Here what we see is what we call camel case, which is a name convention. We begin the first word in lowercase and each next word with an uppercase on the first letter. You want to make variable names that are very short as possible without loss of information. You want the name of the variable to describe what the variable will hold inside. So this variable stores the health of the player, and this stores the total score amount. Not of the player, just the total score amount, whatever that means. You could have here, for example, player score amount. So this variable is self-explanatory. It will hold the player's score amount. And you could, for example, have player money amount. let's say that the player starts with $100. So you can see, guys, how you can use variables to store important information on your game, and then you just go ahead and change these variables to change the values according to the actions the player takes. Pretty great, right? This is pretty amazing. So I want to give you some objectives to play around with data types and variables now, because I think that's very fundamental. I'm hiding some information. So here I've shown you how to create variables with numbers and how to change the values they hold inside. What I want you to do is create a variable with a boolean. And I want you to create also a variable with a string by using this template over here. In the Bible, I give you the answers, but I want you to try it out on your own first. Now, question: why do you put this mark at the end of the code? Well, this is a coding convention. You don't need to do that. I'm just putting this semicolon because it denotes that this command ends there. This line logic ends there. This is just something that we professional coders have been doing for years because we learned with programming languages that made it absolutely mandatory to put it, otherwise your code wouldn't run. And like our code was failing because we forgot this in some line because we were writing code so fast. This is not required in Luau, this is not required in Roblox, but it's always good to have it. It's making the code safer and, well, everybody will be able to read your code. Okay, so that's something that I am doing. You shouldn't do it, you don't need to do it, but I would heavily suggest that. So I put this because I like it better like that. It reminds me of the old coding days. So today you learned variables and data types inside Roblox Studio. This is amazing. Get started, try it out. Welcome back to another tutorial on Roblox Studio. Today you are going to learn arithmetic operations, comments, but also how to test your scripts without playing the game, like fastly iterating a check over what actually happened. Of course, as always, on the link down below, I'm going to have the Roblox Bible, the book that is going to teach you everything you see in these tutorials. So let's begin. First of all, let's open up the script we created last time, okay? So last time we've seen all about variables and data types. So today we're going to see arithmetic operations. There are a lot of operations and you've got, for example, two numbers. The operations you can do between those numbers vary, but they're the typical operations that you know from mathematics and from school. It's the plus. You can do 10 plus 10. You can do 10 minus 10. You can divide two numbers or you can multiply them. Okay? So these are the basic four operations. However, these are not the only ones. And let's go ahead and run the script so we can see the output. And in this case, I'm going to click run here. So on this test menu, instead of doing test, I'm going to do run. And I want you to see the difference. When you click run, your character doesn't spawn. It literally just spins up the server. So your scripts will run, the game will initialize, but it's just that, it's like server side. And we see 20, 0, 1, and 100. So in the first line, we did an addition, subtraction, a division, and multiplication. So now we're going to move forwards to the more advanced operators. The first one is what we call modulo. So modulo is this sign here, and remove the string, I don't know why I put it. So this is called modulus. And what this does is that it allows you to divide 10 by 3, which is actually 3. However, what we keep here is the leftover number. So this is the remainder of a division, which is going to be 1 in this case, because when you divide 10 by 3, the remainder is 1 because the division is not perfect. And usually we use this kind of modulo operation to understand whether a number is an even or an odd. And we do that by doing modulo 2. This allows us to understand whether, 10 is an even number or an odd. If it's an even, it's going to be 0. If it's an odd, it's going to be like 1. So let's see the differences again here. Let's click play on run mode. We see the results here. Okay, let's stop that. And let's see one by one the lines. So 10 divided by 3 has a remainder of 1. 10 is perfectly divided by 2, no remainder, because this is an even number. 11 divided by 2 leaves 1 because it's not an even number. And here we have the exponent operation, which essentially does 10 in the power of 2. If we do this in the power of 3, it's going to be 1000. Now there is a question about what this sign is. So how is this code not running? What is happening? So there is something that we call comments. And comments are very useful to write more details about what you want inside your scripts and your code. Maybe you can explain where something is used, why it is important or whatever. And we do this by putting these dashes and then writing some kind of text, numbers, it doesn't really matter. Anything after those dashes on the right hand side is not going to be executed, it's just comments. It's human readable code that allows people to understand what happens. So checks for even or odd number. For example, you can write this kind of comments to explain what the code does to other people. All right, so this is very useful. And of course, you can combine the result of these operations with, for example, a variable. So here, what we do is we do a modulus operation. We define a variable a that is going to be local to the script. And the remainder of this, operation, arithmetic operation, is going to be stored in a. So if we print the variable a here, just showing you how everything works right now, which is, in my opinion, super useful. If we print a, we're going to see 1, which is the remainder of the 10 modulus 3, the division essentially, okay? So here is how everything can be combined. Arithmetic operations are super useful when you want to improve skills of characters, when you add positions, when you want to do some kind of scaling. It's used pretty much everywhere. You can understand their usages. So some learning objectives of today's video is I want you to create 2 variables with numbers and do all of these operations between the variables, okay? So I'm going to give you a very short example. Let's say that we define 2 local variables, okay? You can go ahead and do a 3rd variable, which is going to be a plus b. Now look at this. What this is going to do is it's going to add a and b, their values, and it's going to store it in the result. So write down below in the comments what this code is going to show us on the output console, guys. This result, what's going to show us? Write in the comments the value and make sure to play around with all of these operators and check the Bible on the description. You are going to learn all about properties, object properties, how to manipulate them through scripts. So before we begin, I want to show you what exactly we're going to be doing. So as you can see here on our workspace, we got, for example, the base plate. All right. So here we can see the properties window. These are essentially attributes, options for our current object part. Tell it whatever you want. As we can see here, we have a brick color, a cast shadow, a color, a material, some kind of reflectance or transparency. So let's say that I want to make the base plate more transparent, more reflective, and change its color to red and material to corroded metal. Okay, for example, I did these changes here. Okay, so we can see how the base plate is changing on our 3D map, 3D world. All right, so today what we're going to learn is how we can do changes to this properties window through scripting instead of going and doing it manually, which is probably fine if you don't change an asset as you play the game. But if you're like changing how assets look or what assets exist, or there's some kind of effect you want to make, you need to do these manipulations through scripts. And the example we're going to see here is manipulating properties. But what you got to understand is that you can manipulate anything that is inside an object's properties. And usually what we do is we manipulate attributes or positions. Okay, so we either change the transform or we change the attributes of a block. But today we're going to do it with appearance just to keep everything simple. So let's open up again our script. This was the script we used for arithmetic operations. Let's clean it up and let's begin. So first of all, what we're going to do is we are going to access the entire game by typing game. So this is essentially a place, like think of it like a variable that stores everything that is inside our game. So pretty much everything you see here, all of this hierarchy is the game. Okay, so this variable in the scripts holds all of these things. So after you type game, what you want to do is click dot, and then you want to select a specific sub option. So in today's video, we're going to go for the workspace, all right? Because we want to access the workspace and specifically the base plate inside the workspace. As we've said in the first video of the tutorials that we're making, the hierarchy matters. And what we do here is that we're accessing through parents to childs using dots, traversing through the hierarchy of our game inside Roblox Studio. So we accessed the workspace by typing game.workspace. Now we want to access the base plate. So we're inside the workspace and the base plate is like that. You just type how the name of the base plate is. And it's very important to always make sure that you give correct namings, unique namings to your items. You can right click on an item and click rename if you want to change its name. Always make sure that your variable names, object names help you understand where the item is and what it's doing. Always have names that you understand, specifically their function and purpose. So we accessed the base plate. So how can we access now the properties of the base plate? It's very, very simple. If you click transparency, we get access to the transparency field. You see how easy it is? It's very, very simple. And what we can do is use the assignment equals and number, and when the game runs, it's going to change the transparency that we have set by default to 55, 0.55. It's going to change it to 1. And you can do this with pretty much all of the other attributes that you see, all of the other properties that you see inside the object. So reflectance, we're going to bring it to 1. Then what we're going to do is we're going to go ahead and change the material. So in this case, what I'm going to do is just change the material, and I'm going to use a string to change the material. This is not what I would suggest that you do when you make a game, even though it's pretty easy and you can see the default options here. But there is also another class that you can use that is specifically for all of the materials that you have available in your game. But right now we're going to do it as simple as that. We're going to see more options in the near future as we progress with these tutorials. So this is how the script can look like, and you can access pretty much anything else you want. Like anything else you want, you can access through this exact structure. It's really, really simple. Like you could do whatever you want. Okay, so again, I want to give you a reminder. Here we've got number data types. Here we've got a string data type. It's very important that the changes you do on each of these, let's say properties, is done on the correct data type. You don't want to go into transparency and write XXX, okay? This is completely wrong. Like this is not the correct thing to do. So make sure that you don't make this little mistake. So let's play the game to see how things change. And obviously we can see that the base plate has changed to brick, reflectance 1, transparency 1. So the script actually works. The change was done. So I want to give you a little bit of an objective for today's video. I want you to go ahead and create a new script, okay? And I want you to go ahead and create a new part on the workspace. And I want you to go ahead and use today's tutorial to manipulate the object, change whatever you want, like the color, brick color, transparency, play around and also try to fail, try to make some mistakes. Doesn't really hurt. At the end of the day, you can just delete the script. So go ahead here and put a string on reflectance or transparency and see the error message, like do that. Let me show you an example. Doesn't really matter. So the value of type string cannot be converted to a number. And we see here, if we click, where the error is at. It's line 2 of the script. So this is very useful. This is how you can debug this kind of errors. Roblox Studio is going to help you as much as it can. Okay, so it is what it is. Make sure to play around with it. Check also the Roblox Bible on the link down below in the description. And I will see you on the next video. Thanks so much for watching. Goodbye. Welcome guys to another tutorial. Today you are going to learn about functions and their parameters inside Roblox Studio scripting. Let's begin right now with the tutorial. First of all, what is a function and what are the parameters? First of all, a function is a reusable block of code designed to perform a specific task. Again, it's reusable code for a specific task. Keep that in mind. Now, let's say that we have a problem. Let's say that we want, for example, to do some print messages. Let's say that we want to print A and we want to print B. And we want to do this again and again. We would have to write these lines of code. We will have to write these code lines again and again and again, which is very boring, and you could like make a mistake and you have to copy them again and again. So what we would do instead of doing that is being smart and define a function that has this reusable code, and we just call a single line of code again and again. So let's see how we can define a function, and this will help you understand what functions are. So we write local function, we give the name of the function. So in this case, it's going to be print ABC. That's what I'm going to call the function. Then we got the two parentheses. This is just typical syntax. And then here you type print ABC, and the function is always ending with end. All right? So this is how a function is defined. And this function, what it does, it prints A, B, C. Now, if we run the code, you are going to see something interesting. We see ABC, but this ABC is not from the function. This ABC is from the code that we wrote here. If we remove this and we run the code again, we see nothing on our window. But what is happening? We defined a function. What went wrong? Well, it's very simple. When you define a function, this doesn't mean that the code will run. You just define a sequence of code to be run when this function is called, when this function is invoked. That's how we call it. Invoke, calling the function. So in order for the function to run, you need to run its name and its parentheses. This is how you run the function. This is how you define it. Local function, end. All right? This is the code between local function and end. This is the name of the function. The parentheses, I will show you in just a little bit what you do with the parentheses. All right? So now we can call the function and print ABC. Again, the call of the function is this one, print ABC parentheses. All right, but first you need to have defined the function. If I rotate those positions around, well, code will not know what the function is. So attempt to call a nil value. That's what it's going to say, because print ABC is not defined. It doesn't know, the code doesn't know what happened. So you need to have the function before you actually do this thing. All right, you need to have defined the function before you call it. Now, what is happening with parentheses? Why do we need parentheses in Roblox scripting? This is so disappointing. This is making me so angry. I don't understand it. Okay, so what we're going to do is we're going to actually print two specific values. We're going to print X and Y, all right? But what is X and Y? The function doesn't know. So in order for us to give values to the function from outside the function, we need to specify what we call parameters. These are placeholders. So a placeholder is essentially a variable that has no value. It's defined on the parameter, on the function definition, and it allows us to plug in values when we call the function. So right now, when we define the function, these are just placeholder. You can do whatever you want with them. In this case, we're gonna print them. You could actually go ahead and do like an addition. You could do like X plus Y, okay? You could do whatever you want. So when you call the function, you need to give values to these parameters. Otherwise, there is no need to put them here. So we could put 5.5. We're expecting to see 5 for this print, 5 for this print, and 5 plus 5 does 10. So the last print will be 10 because we call the function and we place the value of 5 for X, the value of 5 for Y, and these are replaced by code automatically, and everything runs here, and we're good to go. And functions are so simple and so amazing, and you need to use them every single time you can. Just define functions, use them again and again, doesn't really matter. One cool thing that I want to show you about function is what I'm going to show you here. When you are writing complicated print messages where you are trying to debug stuff, there is something amazing you can do with functions. So let me show you this beautiful function, guys. So you got this greet player function, for example, all right? let me show you, my friends. This is the greet player function. It has a parameter name. That's how we call the parameter. Doesn't really matter. You can call it whatever you want. Make sure also function is correctly defined and it has a red color on your coding editor. So here we could say print and we do hello to the game. And then we put a comma here and then look at this. 2 dots, name, 2 dots, boom. What is this going to do? This looks amazing. So it's going to take the name of the player. For example, I'm going to say Aero here, and it's going to put the name in the middle of this big string, and those dots are going to append those strings, concatenate them. That's why we call them. They are going to join the strings, the text. It's going to join it together. But in the middle, it will have our parameter. We will have the value we pass to the parameter, to the function. So look at this. Hello to the game, comma, aero, exclamation mark. This is absolutely amazing. This is so useful. You could do all sorts of messages with this kind of trick in functions. And also very important, the trick here, the most important thing is like the concatenation of the strings. Like this is the trick I wanted to show you today because this is so useful and I want you to know it. So what functions do to our game is they allow us to keep everything organized. It's very organized, guys. You can close the function. You could have like 100 lines of code here. You can close it, say greet player, you understand what it does, you know it works, you don't care about it again. Simple as that. Also, readability. Other developers can see the name of the function, call it with the parameters required, and not understand anything of the code. They don't care. Also, to fix bugs, it's very, very simple when we only have to check a single function. By creating functions, you can test them. You can know a function runs always and it's fine. And if a function doesn't work, you only have to change this function. So you know when the code fails, where it fails. It makes everything so much simpler. So what I want to give you as today's learning objective is I want you to create a script and I want you to try and create a function that adjusts a part. I want you to take this base plate and apply some edits on it. All right? Apply some edits on it. Change its transparency, change its material, simple stuff. These are numbers. This is the data type of string that we talked about. Just make sure to create a function that takes the base plate. You need to watch the second tutorial to understand how to access the base plate through the properties. And then you want to understand the data types and what values you need to put into the transparency or reflectance or to the material. And you need to conduct the change. Again, remember, use parameters to pass in values. All right? Simple as that. Also, in my Roblox guide that we have on the link down below in the description, it's essentially the book I'm creating for you. You are going to have the answer to this question if you go down below in the functions parameter chapter. Go ahead, try it out and let me know what you think. Thank you so much for watching. All right, so today we're going to learn about scope and returning inside Roblox Studio. Now, these are a little bit complicated concepts, but don't worry, you are going to understand it very simply. So let's begin by first understanding what scope is. We have local and global scope, right? Two different versions, two different candidates. So the scope refers to the visibility of a variable. What are you talking about, Iro? Relax. In Roblox, we always use local. All right, this is a keyword that defines where the variable is accessible. So at the top of your script, inside your script, but not inside the function, you can define the variable 1, for example, 1, like you see on screen right now. This variable, even though it's local, it lives on the global space of this script. So at any point inside this script, below, in every line below, you could use the value of variable 1. All of the different code that you write can see it. However, on the local space, which is when a variable is created inside the function, using local stores it only inside this function. Let's see an example. Let's say that we have local function, private room, to keep up with the analogy. Here, we could have a variable. We could write local variable 2 equals 2. Now, as we've said, any variable created inside a function lives only inside this function. again, it should always have local in front of it. So if I go ahead and try to print the value variable 2 outside the function, I will not be able to, because the variable 2 doesn't exist outside of the function, and the code here is outside the function. So if we try to print variable 1 outside the function, it's gonna be fine, because variable 1 is essentially in the lobby, it's in the global scope. However, variable 2 is only locatable, is only alive inside the function. So let's run the code and see what happens. What we see here is 1 and nil. Try to understand which of the 3 prints actually worked and why. Alright, so you thought about it. Variable 1 is 1 and variable 2 is nil. Nil is a value to denote that something is missing, that something doesn't exist. So variable 2 essentially doesn't exist. But why didn't we see the value of variable 2 even though it's already printed inside the function? Well, it's very simple. We never went ahead to print the function. So now think about what is going to happen. I will give you 1 second. Exactly. It's going to show 1, 2, and again nil. Let's run it. 1, 2, nil, as we expected. Think about it, see the script, and understand why these values are shown like that. Now I want to move to something else. Alright, you say, there is this local variable 2 that lives inside the function. Let me give you a little bit of a mindfuck. Let me completely break it down. There is a function, there is a utility that is called return. And what happens with return is that you can return values back to the program. So let's say that we write return 3. When we call our function, after it's called, after it does all of its process, is going to return the value of 3. But if I run the code right now, I'm not going to see the value of 3 anywhere. And the reason is that the function returns it. It brings it back to the code. But this value is not stored anywhere. So what you want to do is create a variable and store the value of the function call. That's what we call here. This is a function call. Go watch the functions video if you don't understand what function calling is. And we store the value that is returned from this function to b. So if we go ahead and print the value of b, I want you to guess what the value of it will be. Is it going to be 2 or is it going to be 3? Exactly, it's going to be 3, because we don't return variable 2, we return the value of 3. It's very simple, guys. See it again, okay? It's very, very simple. So let's run it. Boom, 1, 3. Now, something very useful. Alright, you define functions locally. What's the use of them? Well, for example, you could do some kind of thing here with variable 1. So you say that you want to define variable 2 to be 2 plus variable 1, which is a global variable. And look at this here. You could return the value of variable 2. So tell me now, what's the value of b going to be in this case? It's going to be 2 plus variable 1. Variable 1 is 1, so it's going to be 3. So this function is going to return 3, and the value of b is going to be exactly 3. So you see right now what happens with returns? You can see what happens with local and global scope and how you can play around with them to create pretty much whatever you want in terms of manipulations and arithmetics. Hopefully you do. So what I want you to do is create a variable inside the function and try to print it outside the function as we did at the first part of this tutorial. I also want you to create a function that is multiplied by 2. So what this function should do is take a parameter, multiply it by 2, store it in a local variable inside the function, and then return the value. Okay, so you need to return the value of the local variable, pretty much like we've done here. And in my airdrop, in my Roblox Bible, which is going to be down below in the description, I have a chapter about scoping plus return. You can go ahead and check that out because I have the answer to these questions over there, as well as more material that can help you understand topics more deeply if you want to go over them again. Welcome to another Roblox Studio tutorial video. Today we're going to be taking a look at if-else statements. Now these statements are very, very powerful and you are going to probably use them quite a lot, so pay attention today. Let's begin by first understanding what an if statement is. So what if allows us to do is do condition logic, meaning we have if, then a condition, and then a code block, and finally an end. Okay, so what we do with if statements is we can access specific parts of code only if a condition is meant. And let's write our first if statement to see an example. Let's say that we have a local variable that is x equal 3. Then we only want to print a message to the user if x is equal to 3. So we write if x equals 3, then we add an end and we write print hi 3. All right, so let's understand what is happening here. First of all, we have a variable with number 3. Then we have an if statement and we check if 3 equals. This is a logical function that says if the value is equal to 3, this is equals. It's not the same as this. This is an assignment. This is a logical check. It checks if x is equal to 3. Then, so if this is true, if this result is a Boolean true, because true and false are denoted as Booleans, as we've said on the data types tutorial video number 3 of this course, then if this condition here is true, we print this message. Let's run it to verify that this works as expected. Hi 3, exactly what we expected. All right, so let's go over it again. Once again, I want you to understand this. We have if condition is true, then do this. This is what happens here. And the condition again is x equals 3. If this is true, then we run this code. If you don't understand this, watch it again. If you don't get it, write the code. It's really not going to ever be simpler than this. This is just what we use when we want to do a logical check. Equals. And this is when we want to do an assignment, when we want to store a value inside this variable. X equals 3 is true in this case, and true is a Boolean value. So when the condition, which is what happens between if and then, is true, then we run the code inside the code block between then and the end. All right? It's really simple. Please understand it. So the next thing I want us to see is what happens with multiple condition logic. What we can do to make this condition more complicated. What can we do to make multiple checks in this condition? Not just a simple is x equal 3. So what we can do right now is use some operators that are called and or. So let's begin. Let's create a local variable y equals 9. And if x equals 3 and c equals 9, then print hi 3 and 9. All right. So what do you understand here? It's exactly the same thing, but now our condition is bigger. Our condition is x equals 3, and so both of these things needs to happen at the same time for the condition to be true. Y equals 9. Again, both x needs to be 3 and y needs to be equals to 9. Okay, that's what and, this logical operator, actually does. Do you understand? Hopefully you do. Now, let's move to or. Or is similar. Instead of and you write or. And what happens here is that you only need one of the two things to happen for the condition to be true. So if x is 3 or y equals 9, one of the two happens or both at the same time, then this condition, the whole condition here, will be true. So the code will run. But if both of them are false, meaning x is not 3, y is not 9, the code will not run. All right, but they have both of them individually have to be false for the condition to be false. All right, so let's see the code and we see all of the prints. as expected. Guys, it's very important to understand ent and tor, okay? This is the simplest way I can show them to you without wasting so much technical time explaining them to you. I just really hope you understand at this point. Like, if you don't understand this, maybe it's not for you. Like, put in the work, but maybe it's not for you. Okay, there are also other kind of operators. We got comparison operators. For example, if x is bigger than 2 or y is smaller than 11. And one thing you can do with this kind of operators is you can add logic. Something bigger than something else, something smaller than something else. And you also have like the operator equals. So what you do is greater equals or smaller equals, if you want also to take in the value of 11. So if y is smaller or equal to 11, then print high. And same thing with this. Okay, so there is also these combinations that you can do that give you a larger field of values for your conditions. Additionally, there is the not equals, which is this sign. So if x is not equal to 2, then print hello, right? So this is the not equals, which is exactly the opposite of equals equals. Opposite of equals equals. Okay, so do we get it? Hopefully we do. Let's run the code. Boom, we see the messages. 101, and I hope you get it. Hopefully you do. So there are also some other stuff that you need to know about ifs. If, for example, this doesn't happen, we can add an alternative condition. So if the first condition fails, which is if not equal to 2, we can give another condition by typing else. So we can print, for example, not hello. I don't know. So here what happens is you need to remove the end, and you have if, then, else. So if this doesn't happen, no matter what, this code will run. So if this is not true, this not hello will always run. However, this is not very agile, this is not very useful. So we also have this condition, an alternative if. So we got if, else if, and we have something like that. So if x is not equal to 2, then print hello. However, if x is equal to 3, type hello 2. But if it's not equal to 2 and is equal to 3, it's not equal to 3, then you do that. All right. So I hope you get this point. Okay. But you got to understand that this probably will hit all of the times. So this doesn't make a lot of sense. Like this kind of coupling is not very useful. But I try to show you the different operators. For example, we can say if x is smaller than 2 or smaller than equal than 2, or if x is bigger than 3, hello 2. Eitherwise, print not hello. So if we run this, we are going to see not hello because x is 3. And as we know, x is bigger than 2 and smaller than 3. It's equal to 3, but this condition doesn't capture that. So we're going to go into the else statement. And I want to give you a practical example of how you could use that. And let's just do that before your assignment. Okay, so let's do a realistic example. We're going to go into local, let's type baseplate. So let's create a local variable for baseplate. And it's going to store inside the actual baseplate from the workspace that we see over here. Now we're going to write an if statement. So if the baseplate dot anchored, which is essentially a property of this object. As we can see here, if you scroll, you could see here there is this anchored property. So if this is true, so again equals true, then we want to do the following: print anchored. Okay, and we could, for example, make it, change the value, especially of anchored. We could add a wait flag for 2 seconds and then turn the base plate back to actual anchored. So that's going to be very interesting if we make that. So let's try it out. Let's see how it goes. So yeah, essentially what happened is the base plate for 2 seconds continued to fall, right? So that's essentially what happened. Let me show it to you if we were playing the game, which is gonna be Very interesting. So we play the game and you see we spawn approximately 2 to 3 meters above the base plate because the base plate fell due to the script. So that's what you can do with if-then statements. And what I want you to do, just to play around with it, is create a variable, for example, player power. And I want you to make also a Boolean variable that is has keycard. Now I want you to apply some logic that if the player power is greater than 9000, then you will print hello hero. And I want you to add an else if statement about whether keycard is true to print grant access. Otherwise, print access denied. And I want you to play around with this example just so that you train yourself, that you practice with if, then, else statements. And of course, make sure to check the first link down below in the description that is going to hold the Roblox Bible, which is going to give you a little bit more examples and more in-depth information about if statements. Alright, so make sure to check that out. It's completely free down below in the description, and I will see you in the next tutorial. Welcome guys to another Roblox Studio tutorial. In today's video we're going to learn some of the most interesting things. Yes guys, today we're going to learn everything about loops, and this is a very core, very important scripting tutorial that I need you to be very focused on. By the way, on the first link in the description you are going to find the Roblox Development Bible. It's completely free and you can find the section about loops over here. That's what we're covering today, so let's begin. So guys, loops allow you to run the same code repeatedly. So that's very, very powerful. And that's what we're going to learn today. We're going to learn two types of loops, two types of iterations, for and while. And I'm going to show you how you define them, when to use them, why to use them, some different specifications, and also a practical example. So let's begin, go to workspace, and let's go ahead and create a script. So our script will have a hello world. We delete that, we don't care about that right now. So what we want to create is our first for loop. But before we do so, what essentially we're going to be replacing is, let's say for example, you have like multiple print statements that are like statement 1, statement 2, statement 3. All right. And let's say that we want to print this thing like 3 times for some reason. It's very inefficient to read and write this type of code. This is what loops solve for us in Roblox Studio. Instead of doing that, what we could do is what I'm going to show you right now. We're going to learn about a for loop. So I want to give you first of all the basic structure of a for loop. So a for loop has a counter, which is essentially a variable that has a beginning value, an end value, and a step value. So what each part means. So first of all, to define a for loop, we begin with for. We have our counter variable that equals a number, all right? We have that here, we get it. So our counter begins with 1, it ends at value 3, and each time this loop happens, the value of counter increases by 1. So what you see here is that for counter beginning at 1, we are going to do print statement 1, 2, 3, till counter becomes 3. So 3 times, what is going to happen? We're going to get these prints. Now someone will say, I don't understand the syntax. I don't understand what the step is, what the start is, what the end is, how everything happens. And this is totally fine. You don't have to worry about that. So essentially what is going to happen is this procedure will happen in code. The counter will be set to 1. Then the print statements will happen, so everything inside do and end will happen. So we're going to have this. Then the counter is going to increase by 1 because the step is 1 and the previous value of counter initially is 1. And after that, we're going to have another print, all right? And then the counter will again increase, all right? So here counter is 2. here counter is 3, and this is everything that happens. So let's remove this as well. Let's run the code to actually see if indeed it will be shown 3 times. So as we can see here, we got statement 1 to 3, statement 1 to 3, and statement 1 to 3. Indeed, the script worked exactly 3 times, and after we reached the value of 3, it stopped. Alright, so we've seen how to create a loop. One thing that I wanted to show you is that you can begin with counter 3, go all the way up to 1, but do a negative step of 1. Yes, you can actually inverse the loops by changing the start, the end, and the step. Pretty amazing, right? Let's run it again. And boom, you see statement 1, 2, 3. That's very amazing. That's very, very interesting. So there is also this thing that you can do. I will leave even more details in the Roblox Bible down below in the link, but we have to continue into while loops. So what we're going to create is we're going to create a similar loop that looks exactly the one on top, but now we're going to define it differently. We're going to create a local counter variable equals to 1. And what we're going to do is we are going to say while, instead of for, we say while the value of counter is lower or equal to 3, we want you to do the following. So it's while the variable is lower than something, or maybe equal to true, equal to false, nobody knows. This is essentially a condition, as we have seen in previous tutorials. So while this condition is true, we want to do some things. We want to print this stuff over here. Now, in no case, never run a while loop where this condition will never become false. Because if this condition will be always true, your program is going to crash because it's never going to stop. So how can we turn this condition into false? We essentially increment the counter. So the counter will initially begin at 1 and then print this stuff, go to 2, print this stuff, go to 3, print this stuff, and then it stops. Alright, so this while loop is exactly the same as the for loop. Now, it looks a lot more complicated than just a for loop. However, whiles are very useful when you want to do an iteration till you find a very specific condition. So they're very, very powerful. Don't feel they're not good enough. They're super powerful and super amazing. So I'm going to remove these lines of code and we're going to run this. So you can see statement 1 to 3, statement 1 to 3, statement 1 to 3. All right. So we did that. We've seen it. Looks pretty great. Ignore the errors here. It's from the AI editor. So we see the statements here. And this is how you can define a while loop. So here we have the condition. Again, it's very important that the condition will become eventually false. So always make sure to increment, iterate, or whatever. One interesting thing is that you can bundle loops together. So for example, you can go for outer equals to 1, 5. When you don't put the step here, it means that the step is essentially 1. So this is essentially the same as me doing that. So I'm going to remove the step. Who cares? So for outer variable starting from 1 up to 5 with step 1, we want you to print the value A. And now we're going to loop, actually not loop, nest the loops. So nesting loops means you have a loop inside another loop. So what we're going to do is, this is an inner loop that goes from 1 to 5 with step 1. Again, as we've said, when the step is 1, we can also not define it. It's by default 1. So that's better for coding. You don't always have to show the step. It's a lot harder to read this than this, okay? So for the inner loop, we're going to print B 5 times. So I want to ask you, how many times are we going to see A, and how many times in total are we going to see B? Write down below in the comments, because I want you to think about it before I run it. So write the comments, I give you 1 second. Let's run the code. So as we can see, B is printed 5 times. That's what this shows. B is printed 5 times when each A is shown. So A is shown 5 times, B is shown 5 times per A. So 25 times we're going to see B, and just 5 times we're going to see A. All right? should be pretty understandable. And the pattern is A, 1, 2, 3, 4, B, A, 1, 2, 3, 4, B, A, 1, 2, 3, 4, B, A, 1, 2, 3, 4, B. So this is the pattern that we created here, okay? So let's go with a practical example. What we're going to do is we're going to take local base plate, right? And that's going to be very interesting what we're going to do now. So we go to workspace, we go to .baseplate. We've seen it already in the past. And what I'm going to do is for I beginning at value 1 up to value 10 with step 1, I'm going to set the color. So we're going to do baseplate dot brick color equals, and this now brick color thing that you are going to see here is essentially something that you don't have to understand. It's just a way to define the colors, the brick colors inside Roblox Studio, okay? So essentially you can think of this like something like a string, but we have to use an intermediary, let's say function, or it's actually a method, but we need to use this so we can set this attribute, which is essentially the brick color of the base plate. Again, let me show you. Our brick color right now is really red, and we can see different values here like toothpaste, still blue. You see me as I iterate, this value changes here. So in this case, I want to do, let's say, pastel yellow, I don't know, mosh. Let's do mosh. So I put mosh here. Okay, so we do that. We're going to put a task wait for 2 seconds, and then we're going to change this color into another color. We're going to do, again, really red, okay? And again, we're going to put a task wait. We're going to wait for 2 seconds, and then we're going to change the color again. Oh my God, what Ira is doing. So we're going to change it to navy blue. So let's write navy blue here. Okay, so that's what we're going to do with this for loop, and this is going to be changing the color of the base plate again and again and again every 2 seconds for 10 iterations. So we're going to see each color for about 2 seconds for 10 iterations. Let's check it out. So we see here it's red, it's changing color, it's changing color. So this is what we've done with this simple for loop. We made the base plate change its brick color every 2 seconds for 10 times altogether. Pretty cool, right? So some important things that I want you to be careful of is, first of all, infinite loops. Always make sure to modify the variable counter in a while loop so the condition can become false. Don't do a lot of changes. Make sure always to have some kind of task wait inside loops so you don't crash the server. And of course, in our case, if you want to set the correct color name, you need to use brickcolor.new. And of course, inside the string here, that is color name, you need to have the exact correct specified color name. For this example, you can go click base plate, go to brick color, click on colors, and hover over each color you want, and you are going to see on this section, brick color, exactly what its color is called. For example, this is eggplant, okay? So make sure to use the correct string while you write this code and this example on your own system, all right? So for the next objective for this video, I would like you to do a script that changes a part's color every half a second for 15 seconds, cycling through 5 colors. And I want you to use a for loop and the Roblox task wait function, all right? So I want to see what you can do with this. And essentially you are going to demonstrate control over loop counters, task.wait, and dynamic property changes. Let's see what you can do. Let me know down below in the comments how that went for you. Okay guys, welcome back to another video. Today we're going to cover breaks and continues. And these things that we're going to learn today are very much connected to controlling loops. In the previous tutorial, we've seen everything about loops. The Roblox Bible has also a section about loops and breaks and continues. It's down on the first link in the description. But let's begin right now to understand what breaks and continues do. So let's open up a script. Here, we have like for loop here that goes from 1 to 10. Let's just do a print A here. And we're going to play around with this for loop to create our own break and continue cases. And essentially, loops are very important. But sometimes we need to have control over when loops stop on, for example, when loops can skip a part. So for example, we might want in one case to not print A and print B for some reason. So we need to have the power to, say, if I is 9, I don't want you to print A, I want you to print B. Or if we reach the value of y equals to 5, I want you to stop the loop. For some reason, something may have happened. So that's what we're going to do today. We have this kind of loop, all right? And let's say that we want to stop when we find the value of 5. Maybe our money ran out. So when I becomes 5, essentially what happens is that we don't have any more money for some reason. Or maybe we're testing something and we want to test it for 5 iterations. So what you can do is define an if statement that we've seen in a previous tutorial and say if I equals to 5, then what we want to do is break. So what break will do is it will stop the loop. So when the value of I becomes 5, this will be true. The code will enter here and we'll see a break. So the loop will not continue up to value 10. When I becomes 5, the loop will stop. So that's what break does, and it's very, very powerful. So look at this. We've seen A 4 times, but not a fifth time, because I became 5 and this value, this command never run. Break and this kind of if condition is very powerful on while loops. So let's say that we have counter equals to 1, local variable counter equals to 1, and while the counter is less than 5, we want to do a loop. So we want to print again A. However, here, as we have said, because we have a while loop, we increment the counter 1 time every single time. However, if counter becomes 3, then what we want to do is break. And this is how we usually stop prematurely the while loops. All right? It's exactly the same command, the same logic as the for loop. It changes nothing else. Again, you have some if and you hit a break. That's all. It's really that simple. You use this command to stop loops. There is also another statement that is called continue. So the continue statement, what it does, it skips one iteration of the loop. So let's say that we print A after this kind of if, all right? And we increment the counter right here, all right? Actually, let's do that here, okay? So for some reason, when the counter becomes 3, we might want to not print this value or do something here. So we can go ahead here and instead of break to stop the loop, we can say continue. What is going to happen is that when counter becomes 3 and code runs continue, we're not going to print A. We're going to go to counter equals to false. So continue will not run any code below it when it gets triggered, and it will increase, it will go to the next iteration. In the case of the for loop, if we do this here, it's exactly the same. The print A will not happen and I will be incremented by 1. So let's check that out. Let's say that we print B here and we print A here. Let's run the code. And as we can see, we've seen B 9 times instead of 10, and we've seen A 4 times instead of 5. So as you can understand, the continue indeed worked exactly as we expected it to. If we didn't have the continue, A would be printed 5 times and B would be printed 10 times. So that's continue. It allows you to skip the current iteration and move to the next loop. And today I want to show you how you can add multi-line comments. In previous tutorials, we've seen how you can comment here with a single comment. You use this double dash. So this line will be a comment. It will not be executed as code. However, usually we might write a loop and then we want to stop using it. But the loop has multiple lines of code, and going ahead and commenting each one of these is very boring. And if you want to comment them back out, you need to delete every single line and do this sort of very, very boring technique. So what I'm going to show you today is multi-line comments, okay? Just very quickly show you something. We can put double dashes and these kind of icons, I don't know how they're called. And then this is the beginning of the comment. This is where a comment for multiple lines begin. This is like the command. Then you can end the comment by doing the exact inverse. You put two dashes and these two types of lines. And then after that, we again have workable code. So this is how you can define a multi-line comment. Why would you do that when you have a single line comment? You might want to put loops into a comment so they don't run before you evaluate them again or change something. You can also easily put them back into the game by just deleting 2 lines of code instead of maybe 10 or 20 lines of single comments. You see how easy it was for me to put this back into actually being working code? While just putting 2 lines and like 8 symbols in total, I was able to close this out and this would be never executed. Also, what I really like about this kind of multi-line comments is that you can click this button and the code is just shown as a comment here and you don't have to read what's inside. And this makes code readability very, very good, very, very beautiful. All right. So this is continuous multi-line comments and breaks. Super, super powerful concepts. I also will give you a practical example over here so you can go ahead and check out how loops work with skips and continues more in depth. I don't want to waste your time right now. Make sure to click the link down below in the description to see the Roblox Bible. And yeah, just make sure to check that out. Like, make sure to give this a look. I also gave you a learning objective loop control challenge. So I want you to do an increment from 1 to 1000. Use continue to skip when the number is divisible by 5. So when I mean 5 is I mean the counter value. Use break to stop the loop when it reaches 750. Okay. And include comments about what the loop does, why continue is used for multiples, and blah, 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 okay? And make sure to paste your completed script in the comments for feedback, okay? So you can put the script you wrote for this challenge on the comments so I can give you some feedback. But this is overall what you're going to use. So just read this practical example, change it a little bit to solve the exercise. And in the next tutorial, we're going to see events. Welcome to another Roblox tutorial. Today, we're going to learn about random number generation and also player stats, creating instances, and a lot of other useful things. This is like one of the last tutorials of this beginners series. And I want to tell you that you're doing an exceptional work if you're still following along. Everything you need will be down below in the description in the Roblox Bible PDF. You can actually read it with all of the things that we are going to talk about today. And I will also give you some objectives so you can start writing some scripts and practice. So let's begin, guys. Let's begin with the concepts. So we got a lot of things going on over here. Let's zoom out a little bit, close some stuff. So what we're going to do is we're going to see a random generation first. So let's open up the script. Who cares about what we read before? So what is the random generation? We're going to use a built-in library of Lua inside Roblox. And what we're going to do is we're going to find and we're going to get random numbers between a range. So what we're going to do is define a variable, local random number, which equals, and this is where the random generation happens. We call math.random, right? And what we can see here is that this functionality returns a random number within a range provided. And we see 2 numbers, m and 10. These are just the parameters. So we have math.random 1.6, for example. What this is going to do is it will generate a value that is between 1 and 6, including 1 and including 6. Let's click to print the random number. All right, that's what it's going to do. 1 is the minimum, 6 is the maximum. All right, simple as that. Let's run it and we see the value of 2. All right, every single time you run this, the value will change. Now it became 3. So what we're going to do is we're going to create our first server script. So we're going to go into server script service and add an object, which is going to be a script. All right. What we're going to do is we're going to take this code here, Control X, put it in here. Okay. So we can call it, for example, a dice. All right. So dice has values from 1 to 6. And we can say, for example, that the dice was rolled. So here we print rolled and the random number. This is how you can print also a message with a value. All right. So let's do it. Rolled 5. So boom, we just created a kind of dice that runs on the server. What else? You could use this to randomly change the color of a part. So let's say that we have this kill brick part. We could go ahead and add a script here. And I'm going just to give you the code. I'm not going to type it out. I'm just going to explain to you. All right. So we put a script inside kill brick. So what the script does is it goes ahead and finds the parent of the script, which is kill brick. And while it's true, so this is a loop, we're going to generate random numbers for red colors, green colors, blue colors. This is RGB. This is how you define colors with numbers. So we generate 3 random numbers. And what we do is we apply the color to the kill brick by using color3.fromRGB. This is just a way to define colors using numbers. You don't have to care about what exactly from RGB does. It does what it does. It's just for demonstration purposes. So what we're going to see now is we're going to see this kill brick changing colors every 3 seconds. Look at this. Looks lovely. So this is, for example, another case where you could use random numbers. This is just a very simple example to show you how you can reference an instance through hierarchy, use a loop, use random numbers, assign properties, and do weights. Okay, simple as that. Just want to show you this beautiful example. All right, so that's very, 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 and very, very nice. So I will give you an objective. I want you to build a tower with 5 parts. You can name them whatever you want. Make sure to give them a distinct name, like block 1 to block 5. I want you to place a script in one part that can detect when a player walks into the tower. So do that. And when a touch happens, it starts a loop by changing the color of it randomly, okay? And I want you to send that script down below in the comments so others can access it as well. But now what we're going to do is we're going to start creating instances with scripts. So I'm going to show you how you can create instances inside your game with scripts. So what we're going to do, let's do it. So let's say that we have a script here inside our workspace. We can go ahead and say local new part equals instance. All right. So this is a constructor for instances dot new that essentially returns a new instance. We're going to name it generated part. All right. And what we're going to do, so we're going to create a new part. All right. And we're going to just generate a part, an instance of a part, not generated part. This is a mistake. You want to do a part because here you can generate parts, scripts, folders, tools, blah, blah, blah. So this new part, this local variable holds this instance. And we can go ahead and change the name of the part. For example, we can say it generated part. And we can go ahead and say that the parent of this part is going to be the workspace. So what this is going to do is it's going to do essentially what we would do, like clicking on the workspace, plus sign, part, naming the part. That's exactly what the script does. It creates a new part, so it does the plus button, changes the name of the part, so it's essentially a rename, and adds it to the workspace. So it sets the parent of the new part to the workspace. Simple as that. Let's check it out. So we open up the workspace and we see here generated part. Click on the generated part and then you could right click, zoom to, or click the F button or just zoom to. Where is the button? I really can't see it. Where is it? Where is the button? Oh, the button is here. It's inside the spawner. You can see its outline. All right, man. So this is the generated part. Boom. We just generated a 3D part inside our workspace just by using a script. This is lovely. And also there are some value objects that allow you to store data as instances and make them visible inside the Explorer. In some cases, people use this kind of stuff for leaderboards, leader stats. So there are different value objects like string value to store strings, int value to store 1, 2, 3, 4, 5 integers, and Boolean values to hold flags or toggles. And each of these has a value property that you can write. For example, you can set the coins, that could be a currency or a score, equal value equal to 100, for example. So let's write this code over here that I have it in the Roblox Bible. It's down below in the link in the description, completely free for you to get. Like, you're watching these tutorials, I'm giving you free stuff, freebies. So let's check that out. All right, let's check that out. So let's go ahead here, delete this. So we're going to create a new instance that is called int value. What we're going to do is we're going to give this value coins. We're going to set the value to 0. So we name it like that. And we set the parent to be the leader stats folder. But wait a minute, where is the leader stats folder? That's a great question. So of course, something is missing. So let's understand what's missing. What we're going to do is we're going to add leader stats. So as we can see here, when we play the game, let me show you an example. We can see that the player on the top right hand side should have some kind of leader stats. That's what we're going to try and create. All right, so we're going to add here our coins and the player. So even though the script is not incorrect, it lacks the leader stats folder. So let's create it. So what we're going to do is we're going to say game.players, and for each player that is added, we're going to connect a function. All right, so this function, what it's going to do is it's going to go into leader stats, which is going to be an instance.new, and we're going to put this as a folder. We've seen in the previous tutorial what folders are and how they give a structure. We're going to give the leader stats object, the new instance, a name, which is going to be called leader stats. And the leader stats parent is gonna be the player that just joined the game. So when the game begins, each player here we'll get a folder called leader stats. And now we're going to take this code over here and put it right here. But there is still an issue. Where is the leader stats folder? Well, of course, as you can obviously understand, the leader stats, she's indeed the folder. So you need to change this into leader stats. All right? Simple as that. It's really, really simple. So we created a folder. When a player is added, we create a folder. We attach it to the player. We name the folder leader stats. We also create an instance of coins that's going to have an integer value starting from 0. We're going to name that coins, and we add this instance to the leader stats folder that is inside each player's folder, or each player's like reference inside here. I don't know what this is called. Let's see. Just a player. All right. So what we're going to do over on top of all of these, we're going to do a while. So while true, we're going to add a wait flag of 2 seconds, and we're going to go into the coins value, and we're going to give them some kind of passive income. So every 2 seconds, each player is going to be getting an extra value. But let's do it nicely. Let's put a random value from 1 to 3. So it's completely random, the reward that the player gets every 2 seconds of playing the game. They could get 1 coin, they could get 3 coins. Okay, so we also add here this element of surprise. And we could also add a new instance here. So let's call it playtime. So let's create this instance.new, and we're going to put again int value. There are, of course, as we've said, different kind of values you could have. Let's call it playtime. Let's begin it with value 0. And again, we add it to the leader stats folder of the player. And what we can do here is every 2 seconds, we could add playtime to the player. So playtime.value equals playtime.value plus 2, because 2 seconds have elapsed. And what this script is going to do, we're going to see live right now. Let's click play. And interesting, did anything actually happen? Or maybe nothing happened? Click the leaderboard and we see the playtime here. So if this is not open for you, you want to go into this button and click the leaderboard, all right? It's not always open by default. So we see here that we have our playtime that is increasing, our coins that are increasing, and our name. So if we open up players, we can see inside our player the leader stats. We can see the coins and we can see the playtime. These are int values, both of them, and boom, you just created a leaderboard. You track the progress of the player, their playtime, their coins, and this is beautiful to see. All right, guys, so that was, in my opinion, a very useful, very big, in-depth tutorial. Like, this was pinnacle of coding today. So I want you to try and extend the script, add gems, another int value that starts at 5 and decreases, for example, by 2 every 5 seconds. Add a Boolean value that says whether a player has Roblox Premium or not, okay? So try to do this kind of things. For the Roblox Premium subscription, it's going to be a little bit complicated. You might have to read the documentation for how to get the premium value, but I think it would be a very good practice for you, and it will get you to search the documentation. And one of the core things while you code is you need to investigate. Use Google, just use AI, try to find the answer, try to find the solutions, all right? So that's your quest for the next time. And we're really near the end of this tutorial series. I want to thank all of you for being very, very supportive and sticking around. We got 2 more amazing tutorials for you coming soon for this package. And very, very soon we're going to move into GUI creation. So I'm really hyped for that as well. Welcome back to another Roblox tutorial. If you're still here, this means that you actually have taken the time to learn Roblox scripting. Today we're going to learn all about find first child and wait for child. Essentially what we're going to be seeing today is parent-child relationships inside Roblox Studio. So as we can see, games are structured. We already know it. There's a workspace, there's a players tab, there's lighting, but also there is structure inside the workspace. The workspace is essentially the parent of all of the childs. Camera, terrain, script, spawn location. All of these are childs of workspace. And the workspace, again, is the parent of all of these. Same with players. Players is the parent of the legendary arrow. The legendary arrow is a kid of the players. Okay, simple to understand. That's how it goes. There is a hierarchy. All right. So there is something inside Roblox that allows you to group different parts to make them a single unit. This is called models. So let me take this part here, put it here, all right? So let's say that we duplicate it, Control D, and we have 2 of the same parts, all right? So I'm going to say that this is like part, 2, okay? We got it? Hopefully we do. So what we can do is we can select both of these parts by just clicking Shift, or if I'm not mistaken, also Control, and we can right click on them or click Control G to group them as a model. Let's check it out. Control J, and we have a model. What this model does is it groups different kinds of parts, okay? So if I go right now inside my editor and I click on one of these, we get the whole group, the actual model. This is ideal if you create complex models that should behave as a single entity, and you can move the whole model all together. So this is very powerful. There is also another structure that is similar. So that is essentially the folder. So if you go on plus sign here, you can create a folder. We could put both parts in. So what's the difference between a model and a folder? The folder is a general organization tool. It can contain parts, scripts, whatever you want. And there is also something else. In the folder, each part retains its individual selection. So if I click here on one of the parts, it only selects one of the 2. So it doesn't group them as one. This is very, very good if you want to just put some organization, but you don't want to change the behavior. You don't want to add them as a single unit. You don't want to connect them, let's say. All right. So I wanted to get a little bit of an understanding of the existence of folders for organization and models for grouping. Okay. So what we're going to do right now is we're going to check some functions. The first function we're going to check is find first child. Okay, that's how it's called. So let's open up a script. I'm going to pretty much delete everything here. And what we're going to say is we're going to write a local function. So let's say local function object, and we're going to go into parent find first child, and we're going to say here part. So what the fuck did I just make? Doesn't make any sense. So what this is going to do is it's going to actually try to find the parent, but parent is not defined. What is the parent? Doesn't make any sense. So let's break it down a little bit. We have to define the parent. So what could be the parent in this case? Let's say local parent equals script.parent. So what this is going to do is it's going to see where the script is located inside our game. And as we can see, the script is located inside the workspace. So the parent of the script is the workspace. So the parent here is the workspace. So this is going to be the workspace in this case. If I move the script inside part, for example, like that, the parent of the script is going to be the part object. All right, let's move it back. Move it back. Move it out. Oh my God. No, move it out. Okay, we moved it out. Great. All right, so we got it now. We got how the parent relationship works and how this could change. It's very important to understand that this is a game-breaking bug. If you move scripts without checking here what happens, you could break your whole script, you could break your whole game. So be very, very careful. Be organized from the get-go. So what we're going to do here is I'm going to rename this into model because I really, really hate the word parent. And I'm going to put both of these things, actually this script, inside part. Okay, so now the parent of this script is going to be a part. Okay, follow it. So super simple. Just put the script inside the part. And I reference it as model. So let's see what happens. The code is going to go inside our parent object with the part, and it's going to try and find a child. A child is an instance with a given name that is called part. I have a question for you and I want you to answer it to me down below in the comments. Is this going to work? Well, it didn't. But why did this happen? The reason is very simple. There is no part inside part. So this is completely wrong. So if we want to make this work, we would put both parts inside a model and put the script as part of the model. All right. So let's add some more things. So let's say that this is part, okay? And then we're going to say that if we're going to print the part, okay? Let's print the part. So we can see here that the part indeed exists. So what you can do whatever you want if the part exists. If I click part 1 here and I try to print the part, let's see the mistake. It says nil. Nil means not existent. It's a way to denote that what you search for example, part 1 doesn't exist. We have part 2, we have part, but we don't have part 1. Okay, so what we can do here is we could do a check. So if part, which means that this is not nil, essentially, this is what this check does, you can essentially go ahead and do part.brick color. We have seen it always also in the past. We could change the brick color of the part we found. So we could do brick color.new cocoa. Okay, so that's what we can do. So here I'm going to select part instead of part 1, which doesn't exist. So what this is going to do is going to find the first part and it's going to change its brick color. Okay, let's see it. And boom, we can actually see it. All right. Okay, so cocoa didn't actually exist and I liked for a bit, but I put black color and it works. Okay, so just change this to black. So it indeed finds the part and it changes it to black. And here you can see I'm making mistakes live on this tutorial and it's okay. You don't have to worry about it. Also, one of the things that you need to understand is that when you play the game and the script does a change, this change doesn't persist when you stop the game. So you can see that the part is back to red color, even though in game it will be black because the script runs when the game begins. Okay, just hope you understand this as well. So why would you use find first child? You can prevent errors when objects might be deleted. You can have safety checks like this if, and it's very good to handle dynamic games, all right? So it's a very good thing to do. However, I want to be very honest with you. This is not my favorite event, all right? It's not my favorite function. My favorite function is the wait for child function. So the wait for child function, which is this one, allows us to wait till this is in our game, and then we can actually go ahead and do whatever change we want. So in this case, there's a very big benefit. There's a very big benefit because this will wait till it finds this part, and it will not run any of the other code that we see here if this doesn't get populated. So while this part cannot be found, for example, part 1, no other code will run below this. So let me show you. All right. And when we run this, what we're going to see very soon is an error message. It says infinite yield possible on this part. This means that the workspace cannot find part 1. So what happens is the script is stuck at this point and cannot continue. If we change this to part, click save and restart the game, let's do that, we can see, boom, that the color changed because the game found the part and changed its color. So I really like wait for child because it's very, very safe. If it doesn't find the part, you don't have to do any checks. It's just not going to run the following script. So I really, really like it, this wait for child. I really, really prefer it. So let's see a practical example. Let's create a kill brick. Okay, so what we're going to do is we're going to create a part named kill brick. So let's go here, create a part. This is the part. Let's put it down here. Let's put some kind of blue color and let's rename it by right clicking and going to, where is the rename? Oh my God, I'm really stupid right now. Why am I so stupid right now? Okay. Oh, no. Where's the rename? Here it is. Okay. Kill brick. Let's call it like that. And what this is going to do is when we touch it, we're gonna die. Oh my God, this is very scary. So let's go ahead and create a script. We're going to take this script actually and pull it inside kill brick. I'm going to delete everything. So let's create a local function called killbrick equals script.parent. Let me add the comment here to help you. This is going to be the killbrick part, okay? Because again, the script is inside killbrick. So the parent of the script, so .parent is the actual killbrick part. And we store this into this killbrick local variable. So let's go killbrick.touched. Where's touched? Okay. We're going to also use autocomplete when we can. We want to connect a function with it. So when this is touched, we're gonna do function, other part. And what we're gonna do in this case is very, very simple. So when another part touches it, we're going to do local humanoid, another local function. Always try to have function as much as possible. Another variable, I'm sorry. So we're going to take the parent of the other part. So in this case, it's going to be our player. We're gonna find the first child and we're going to search for humanoid. I'm going to explain a bit why this will work. And if the humanoid exists, then what you're gonna do, this again is a logic case, a fallback. So if the humanoid exists, so if this exists, then what we're gonna do is we're gonna set the health of the humanoid to 0. You could also do this instead of a kill brick, you could like reduce the health, let's say by 10. So you could do -10. All right, so let's try it out. Let's play the game. So this is the script. We go here and boom, we're dead because our life is falling super, super fast. Let's try again, touch it a little bit, lost a little bit of health. So if we go into players in the workspace actually, and we open up our character, we can see that there is a humanoid here. The parent of the humanoid is the player, all right? So let's see the script here. So the other part is essentially the legendary aero model, which is the player. So actually the other part is just a part, a head, the left foot of this. So what it's going to do is going to find the parent, which is the legendary aero, and the legendary aero has a child, which is humanoid, all right? This humanoid, if I'm not mistaken, has some kind of health attribute. Where is it? I'm not exactly sure. Here it is, health, 100, all right? So what we're going to do is we access the game attribute that is health of the humanoid and we reduce it by 10 every time this is getting touched. You could also add like a wait here, wait 2 seconds, for example, so you don't kill the player instantly, all right? So let's check it out again. Let's give it another try. This is very, very useful for pretty much anything you create in Roblox. Boom. Okay, died very, very fast. So as you can see here, this didn't really work. And the reason is very simple. You need to do what we did in the previous tutorial with events. You need to add a flag that checks whether it was touched. If it was touched, just wait for 2 seconds, have the logical ifs. And that's what I want you to create. I want you to go ahead and use the previous tutorial with this tutorial to make the kill brick kill you by 10 health every 2 seconds. I've given you 8% of the code in this tutorial. You have the other 20% on the previous tutorial. Go ahead, write the script, and write it down below in the comments so I can review it and give you some feedback. But play around with it, it's going to be a huge learning lesson for you. Thank you so much for watching. Don't forget, we have this Roblox Bible on the link down below in the description, completely for free, and it covers everything you need about everything we do. Alright, so make sure that you go ahead and check it out, alright? Welcome to another Roblox development tutorial. Today we're going to talk about Roblox events, and here is the Roblox Studio. Let's begin. Again, don't forget, on the link down below in the description you are going to find the Roblox Bible, a PDF document that you can review with all of the concepts we've discussed up till now and all of the new concepts that I will be adding every single day, every single week. So, what are events? Events let your game react to what happens. For example, a player joining or some kind of objects in your game getting touched, meaning someone goes and touches them in game. So let's begin with two concepts today. Player added, so when a player is added to the game, and when an object is touched. Of course, there are a lot more events, but we cannot really cover them in this introductory tutorial. So let's go to Roblox Studio and, let's add a new script, or maybe let's use one of the old scripts, okay? So what we're going to do is we're going to write here our code for events. So first we're going to cover the player added event, all right? And this is how you write a comment. I'm just doing a small revision for you so you don't forget the previous concepts. So we go to game.players, and this is how we access this players component. This is where our player will live. This is the player objects that join the game. And as we can see, there is my character, which is the legendary arrow, okay? So game.players, again, as we've said, game is the component that holds all of the game, including workspace, players, lighting, pretty much everything you see on the Explorer. Players is for the players that play the game, and we want to do player added. So as we can see here, let me just show you. We can see that there is this player added component and it has this icon that is for events. As we can see, before we type it all in, the auto-completion will say this is a Roblox script signal, an event. It fires mean it activates when a player enters the experience. An experience in Roblox is essentially a game, a third-party game. You can also click here to see an example of how this can be used. And of course, you can also open the documentation. It will go to the website and show you even more stuff. So let's say that we have created the event. If we want to attach some kind of callback, what we want to do is we want to go into the connect event. What this will do is it will connect this event to a function that will get triggered when this event happens. So what this does is that when a player is added, we add the connection to a function. Now there are two ways to go about this, but I will show you both of them. The first one is what we call an anonymous function. You write function, yes, exactly, function inside here, okay? Space for and this is pretty much a function that is only triggered, only called when the player added event happens. And it's an anonymous function because we don't need to define a name for it. It's a local function and we don't even need to define local here. This only gets triggered, this only runs when the player added event happens. And this is a very good way to connect functions to event when this function is not going to be used anywhere else. So if you create a function that is only useful for only this specific line of code you will never use again, you can define it as such. This is a very good programming practice. So when a player is added, we're going to say new player joined. So we're going to do whatever we want. It's a typical function. And what we can do is also print the player. So we could say player here, but a better way to do that is say .name. But wait a minute, there is a mistake here. What player? What is this? The code doesn't understand. So we gotta pass the player as a parameter here. So what happens here is that this event will give us a player object. And by using the parameter, this object gets passed into the function. As we have seen, parameters are there to allow us to get values inside the functions. And this event, if you read the documentation, passes the player object into this function. And let's say that the player has a name. So what we're going to do is we're going to print the player's name, okay? So if we do player dot, we can see some different kind of stuff. We can see the name, which is an identifier of the player instance. We can see the team that the player is associated with. We can see another signal that is an event. We can see the parent of the player, and we could actually see the user ID. So the most useful thing here is to see the user ID. So let's run this. So we join the game, and on the output, we can see my ID. I'm not really sure if this is safe. Hopefully it is. But this is how this event trigger happens. So it goes, finds my player, which is passed as a parameter, and prints my user ID. Pretty nice, right? So a lot of people will say, okay, let's do this differently. Let's say, for example, that this function over here, we want to reuse in other steps for some reason. So what you can do is take the function outside. But what you will have to do to make this a functional, function, a function that is actually correctly defined, is you need to add local. So this is going to be a local function inside this document, and say on player added. So give it a name, essentially. And then you want to take the name of the function and put it into the connect. It's very important that the function is defined or imported before you add it to the connect. If you put the function below this point, the code will not run, because at this point the code doesn't know what this onPlayerAdded is. So make sure that the function is defined, this is the definition of the function, before it's used, before it's referenced, before it's called on the code here. And the functionality is going to be exactly the same. A good programming practice, and we can see the result here, by the way. A good programming practice, guys, is that when you want to create function for events, adding on in front of the function name, which is player add essentially, you add on top to denote that this is a function that happens when a player is added. Okay, so that this is a function for events. So that's a good programming practice, okay? And both style works, but you could use this function elsewhere. For example, you may want to print the user ID for a player. Maybe you want to use it in other places as well. You could say, for example, you could call it like print player ID. Maybe this is a bird name. So when a player is added, we print its player ID. And you could potentially also create another script like it's so message, for example, all right? So there's a so message, we don't need the player, no parameter needed, and maybe you could do it like that. So what happens here is we have two functions that are getting called when the player is added, and we can see it here. New player joined, this is the ID, boom, works perfectly. All right, guys, so you could play around with these things. You are not in any way limited from running multiple functions on events. It's just the way it is, okay? So hopefully this is helpful and understandable for you. Now let's move into something more interesting. Let's create a touched event. So as we can see in the workspace, we have multiple objects, all right? Let's say that we have this object, this part, and what I'm going to do is I'm going to anchor this part. This means that when we touch it, it's not gonna move. So here, what I want to do is create a script that when my player goes ahead and touches this object, this part, we're going to see some kind of message, okay? So let's go ahead and do that. So we're going to open up the script here, delete everything, and we're going to say local touch part. So we define a variable that will hold the part that is going to get touched. We're going to go into game.workspace.part, which is the name of the part. Again, I have covered what this is in a previous tutorial. It's very simple. You go into the workspace of the game and you find the part and you save it in a local variable, okay? It's very, very simple. So when this part is touched, okay, what we're going to do is call the touched event, and this kind of part has multiple other events and various options, properties. There's so many things. Really, it's endless. We're going to connect this to a function. I'm going to just use an anonymous function in this case because we really don't need to do anything else, okay? So when this is touched, what we're going to do is we're going to print something. I'm not gonna say here right now. I'm going to show you in just a bit. So let me explain. what happens here is that this event will get triggered when a part gets touched by another part. It could be a bullet. It's important to understand. This doesn't mean that a part is touched only by a player. It can be touched by any other part in the game. And our player has some kind of humanoid part that can get detected by this function, all right? So this function has as input another part. So this other part is the part that actually touches the part here, okay? But we reference it as a parameter as we did previously with the player. In this case, we call it other part, which is the part that touches the part we have defined here. Oh my God, this is so bad. So here, what we're going to do is we're going to print the name of the other part, okay? And we're going to use string concatenation. So what we're going to do is we're going to say that the part's name is going to say touched part. So in this case, it's probably going to say, I don't know, maybe the legendary arrow touched part. Let's check it out. Let's run the script. So I'm here. Let me go super fast to this part. Oh my God, why did I put it so far away? Makes no sense. But watch here what the output says to see if the script actually works. All right, let's go. Come on. Boom. Oh my God, what is happening? So many things are triggering right now. We can see here, head touched part, right hand touch part, handle touch part, humanoid root part. What are all of these parts and why they triggered so many times? If we open up layers and go to actually workspace, on the workspace, my character is the legendary arrow. This is my model. This is my character. My model has different parts. It has a pants part, it has a shirt part, it has accessory parts, it has this humanoid body that also inside of it has parts and all of these things. So every single part of my character could potentially have touched this block. And we see it over here. For example, head, left hand, we see all of these different mesh parts and all of these sorts of things, okay? So that's what we see. We see these kind of things that are part of the legendary arrow model, okay? So all of our parts of our character have been touching this block, okay? And that's what we see on the prints. Now, do you always want to do it like that? Well, maybe it would be more useful to add a variable that say touched equals false. And actually the best way to do this is touched. Now let me explain. This is a coding style that says that Boolean variables, true or false, need to be like is. So it denotes that this variable is a Boolean. So always put in front of your Boolean variable names the verb is. So what we're going to say is if is touched, then, which means that if this part is touched, then what you are going to do is wait 2 seconds, okay? And then print the name, all right? But there is a problem. Is touched is false. So why would this ever run? That's a good question. Why would this ever run like that? So what you would have to do is that when a part is touching, you need to turn this into true. And when this turns into true, you wait 2 seconds and then you print the part names, all right? Also, what you can do is you could, for example, put this inside here. So the print happens inside here, all right? But now there is another problem. Is touch is never happening back to false. It's always going to be true. So you need to set it to false again back here before this function ends. Let's check it out. This is probably also wrong, but I want you to play around with these things and get to understand how everything works, to understand the flows. Okay, so let's check it out. Let's see what happens. Boom, it printed the parts. If we go away, it's gonna do again the same. So it's not working like we want it to work. So let's see how we can fix it. So initially, the touch is not part. The part is not touched, so it's false. That's great. But when it triggers, what we want to do is to say, if the part is not actually touched, then what we want to do is say that the part is actually touched because the event triggered. And when that happens, we want to print the name of the part that touched it. Then we want to wait for 2 seconds, and then we want to do this, all right? So that's what we want to do. That's how we want to play it out. So let's try it out. So we're running. Let's go back to the block. So boom, handle touched part. We see only a single message. Then another part touched it. Then the left hand. then this and that, and we see only a single message. This is great. Okay, so you got it. This is how it works. I showed you the mistake. I showed you how to fix it. And I want you in the comments to tell me why the initial function was wrong. What went wrong with the flow? And what I want you to do is also try to change the color of the part. So when it's touched, instead of printing, I want you to go ahead and change the color of the part. Now, which part are you going to select is the question. The other part or the touch part? Play around with it. I'm not going to give you the answer because this is going to give you an understanding. If you do this mistake, you will understand what the touch part is and what the other part is. You already can understand, but I want to see what you are going to make on your own. You need to fail while you write code. Don't worry about making mistakes while writing code. It's the best single thing you can do. Fail as much as you can while coding and try to debug, meaning fix your mistakes and learn from them. Welcome to what is the actual final Roblox tutorial for this beginner series. The next one will be about creating a game. So today we're going to master tables in Roblox Lua. We're going to create arrays and dictionaries, learn how to access and modify the elements, and use a lot of different functions such as loops, pairs, hypers, inserts, removals, and how to search inside of these. It's going to be very interesting. This is a very useful thing to learn. And after this tutorial, you are going to be pretty much quite good equipped with the basic stuff about Roblox scripting. So before we begin, an array is an ordered list of values accessed by a numeric index. And it begins from 1. Usually in coding, arrays begin with index 0. In this case, it starts from 1. Dictionaries are key-value pairs, where keys can be strings or variables. And finally, we have tables, which is essentially the general Lua data structure that acts either as an array or a dictionary. So let me show you some examples of what each one of these are. So the first one is an array. It begins with this I don't know how to say it, characters, and it stores different kind of values inside of it. This is index 1, index 2, index 3, index 4. And this is a dictionary. So this is how a dictionary looks inside Lua. It's better also to open it up like that, it's more readable. So it's key value pairs. The key is this one or this, and the value is 15 and 4, all right? It's just pairs. So these are pretty much the same. This is like an index that has a specific value. We call it key. And here the index is abstracted away from us. So that's just the very bare minimum example of how an array is shown and how a dictionary is shown. And these are the table data structures inside Lua. So let's create an array, all right? So let's say local array 2. We use these kind of characters, open and close, and we put elements inside, all right? You can put elements of different types, doesn't really matter, it's still fine. And it looks like that, all right? So we defined an array. So as we can see, in the first index of the array, we have the value 5. In the index number 2, we have the string G, etc., etc. So we can go ahead and print the array 2. We can print the first element, we can print the second element, and we do it by using brackets, using the index value to access each position in the array. All right, see it like that. Let's also run the code to see the output. So it's 5G through 200. All right, very, very simple, very, very beautiful, very, very clean. All right. So how can we add and remove elements from this array 2? We can go ahead and say table.insert, and this appends the value at the end of the array. All right. So the first parameter argument is going to be array number 2. So you need to put the array value first and then the value you want to append, for example, 4. Then we can go ahead and print everything here, and we're going to add the index position number 5. All right, let's do that. So we can see that the value was added on the second print. It says 204. All right, simple as that. That's how you insert stuff inside arrays. Let me remove that part as well, just to simplify everything. Let's also remove that. All right, simple as that. How can we remove an element? To remove an element, we do table.remove. We again add the array2, which is the local variable that holds the array. And then we have to specify the index, the position of the element we want to remove. Let's say, for example, that we want to remove the element in the position number 1 and print everything again. Let's do that. So as we can see, maybe this is not a good print. So as we can see, we added the value of 4 and then we removed the index number 1, which is 5. So let's print the 4 elements that will be finally in the array 2. We see G, we see true, we see 204. So indeed, we added 4 at the end and then we removed the first index. All right, simple as that. And also what we can do is use the function that is called table.find. So table.find. So what find is going to do is you again pass the array in the first value and then you want to tell it the value you're searching for. Let's say, for example, that we search G, okay, string G inside array 2. So it should return, if I'm not mistaken, the position number 1. Because here we see it in position number 2, but after the removal of the first index, it's going to move to index number 1. So the result of this should be 1. We can, save the index in a local variable that we call idx, but this is usually used for indexes. So if id exists, always make sure of this check. Maybe what you're searching inside the table, inside an array, doesn't exist. So this check is good to avoid errors. You could print like that the index, so idx, all right? And you can also add the null statement. So if you don't find it, well, whatever, just print not found. So let's check the result. Found at index number 1. Great. So it worked as expected. You can also loop through an array. For example, you could write for I equals 1, and by using this character, you can denote the length of the array, okay? So you begin from the first index up till the end of array 2, and what you could do, you could print like the index or the value I in this case, and the value inside of the array in position I. So it's going to show 1.g, 2.true, 3.200, 4.4. Okay, let's check it out. And it did 1g, 2 true, 3 200, 4 4. All right, simple as that. That's a very easy way to iterate over arrays. And we're going to see even more ways to iterate over arrays. For example, what you could do is for underscore num in I pairs, put array2 here, do, and then you can print number. So what this will do is it will use the I pairs function, which is an iterator function that iterates over the array. It gets two things. It gets the index and it gets the value of the index. And right now we just print the value of the index. Okay, so let's remove this. Let's also remove this and let's run it. And we see G true 204. All right, simple as that. Here you can also go ahead and use idx, for example, and print two values. Print the index and print the value found in the index. So we see 1G, 2 true, 3, 200, 4, 4. So it's pretty similar to what we did before, but it's a lot cleaner, more understandable, and you should absolutely use this, absolutely use this. And what this does is it sequentially indexes the loop. So it goes index by index from index 1 to the final index of the array. So it's going to do it sequentially. And it's very important to distinct this from pairs. So there's also pairs function, iterator function, that it's not going to do this index by index necessarily. So let's see the differences between those two. It's easier for me to demonstrate what happens and the syntax instead of just trying to explain it to you. It's pretty simple. Like this is the index, this is the value inside it. Again, the array and the dictionaries are both key value pairs. And let's check it out. So 1G, 2 true, 3, 200, 4. Boom. All right. But this is an order. So you cannot rely on the pairs variable to always be ordered. Okay. Don't rely on it to be ordered. Very, very important. So let's move to dictionaries because dictionaries are a lot more useful, to be honest with you guys. Like, especially for Roblox, you are probably going to be using them. So let's create a dictionary. Let's call it a menu. And we again define it initially just like we did previously. We're going to have a cheeseburger, and this is how we can define the key of the dictionary, and we can say equal to 15. So this is the value for the index cheeseburger. Then you can have cola for like Coca-Cola, and you can define the value 5. let's keep it simple. I don't want to complicate it for you. So this is how you can define a dictionary with string keys. You can also use variable keys. For example, you could do local cola equals 5, okay? And you can create a local menu too that has burger, that has cola equals cola, and burger equals 5, all right? You have these two different kind of approaches on how you define your dictionaries. So how can you access elements inside each one of these? For menu 1, what you could do is print menu brackets and select the string of what you want to see. So here, cola is the key value in string format for 5. So if we say cola here, it's going to return the value of 5 because inside our menu, we access the cola field that has the value 5. So that's what it's going to be printed. Let's check it out. Boom. Really, really lovely. Also, you could go ahead and do menu.cola, which is exactly the same thing. It's more code-wise related if you do it like that. So again, we're going to see the value of 5. So you can use whatever syntax you want. Doesn't really matter, at least in my opinion. Also, if you want to change the values here, what you could do is go ahead and do menu.cola equals to 20, all right? And then try to print its value. So it's going to go into the menu, find the cola key, and change it to 20, and then it's going to print 20 here. Let's check it out. Boom, 20. All right, so you've seen how you can access and modify dictionaries in this case. You can also iterate over the elements like we did with arrays previously. So again, we have key value pairs, but in this case, the keys are not going to be 1, 2, 3, 4, 5. They're going to have an actual string value. So as we can see here, we access it with a for loop, with a pairs variable, and we concatenate the item, which is the key, with the value. Let's check it out. Let's run it. I'm moving quite fastly in this tutorial because I really expect that you are very, very good at understanding the topics and the concepts. It's literally everything we have worked on till right now. So I don't want to waste your time. I want to show you everything super, super fast. Like you are going to experiment so much with these that you are going to become an expert. So for people asking, I'm really, really a big fan of using this syntax instead of this syntax. And I'm very big fan of accessing everything with dots instead of brackets and strings, okay? It's just so much simpler and safer to code. Also, as we can see, the pairs are not ordered. So if you want ordered, you need I pairs. As we've seen, cola was printed first, even though it's the second element. So be very, very careful with that, guys. It's very, very important that you always make sure you don't mess this up, all right? And as you can see, I pairs is not working here because this kind of array is not using keys that are numeric. So I pairs is not gonna work here. Be very careful with that, okay? Order matters in many cases, so be very careful. Do additional checks if you need to. So how could you use this kind of thing to your games? How can this be useful? So what we're going to do is we are going to code some more stuff. So let's say that we do local model equals game.workspace. Just follow along here. And let's say that we want to access a model, all right? We have a model here. It has two parts. If you don't have this model from previous tutorials, just make sure to create a model and add inside of it two parts. So we reference this model here, save it in a local variable called model, and we can do an iteration. This symbol just says ignore it. I don't care about the value that is here, just ignore it. So in many cases, we don't care about the index, we just care about the value, okay? So here we are going to iterate over the pairs that are inside our workspace model. So we go model, we call this to use the get children. So get children is a very useful function that you can use to access the elements inside your workspace models, okay? So what it does, it returns an array containing all of the instance children. So what are the children of our model? If we open this up, we see part and part 2, All right, so that's what happens. It returns an array that holds part and part 2. So what it does, it's essentially like this. We will have like part and part 2. So this is what happens in here. It's like that. All right, but it's done dynamically by accessing the model and checking its children. All right, so what we can do is go ahead and print the part.name. All right, and while we do that, why not go ahead and do part.brick_color? So we access all of the parts inside there, and we do brick_color.new, and we could do like a burlap or whatever. I don't care. So what we're going to do is we're going to print the part name, and then we're also going to change its name, its color, its brick color, because why not? And boom, we can see here we access both parts. We see part 2, and we see their color is changed. All right, simple as that. Really beautiful. So you can see an actual useful use case of this kind of stuff and how everything is connected to everything. Arrays are used to store items inside Roblox Studio. You're going to use them so much to create inventory systems, and you can iterate over everything to set properties, check stuff, do all sorts of things. So you can see how everything is connected and everything is shaping up super nicely. So your learning objective is to build a very simple inventory system, and you know, I'm gonna do it together with you here. So the first thing that we want to do is create an empty table inventory. So what we're going to say is local inventory. Follow along. Let's do it together, guys. Let's do it together. I don't want to give you homework. So we create an inventory, which is an empty array. Then we want to insert elements. So we are going to use our insert function that we just learned. Okay. We're going to place inventory. Again, as we've said, we put the array as the first argument of the table insert. And then we're going to add the sort. Boom. Then go table insert again into the inventory again, comma, shield, and maybe add another element, inventory, comma. And here we could do something interesting. Let's add an array that holds a position and the value of 3. Very interesting. And then let's go ahead and remove the second element from the inventory because we can do it. So let's go ahead and do some more stuff. Let's go ahead and create a prices dictionary. So for the sword is going to cost $10. The shield is going to cost $5. Make sure to name everything correctly, yeah? And we're going to add a potion here with a value of 10 or maybe 20. All right, so we can go ahead and print our inventory with the prices. So for each item in iPairs inventory, so we do this to continue having structure. As we've said, iPairs for numeric arrays like this one keeps iterating by incrementing the index from 1 till the end. So we're going to view the items in order that were defined and added to this place over here, to the inventory table. All right. So here, what we're going to do, if the type of the item, this is a very good way to check what type of item you have, equals string, then we're going to print the item, string concatenation that we've seen early on, dot, we're going to access the prices dictionary through the item string. All right. Simple as that, right? We know that, we understand this coding concept. You can also remove that, doesn't matter. Let me do it like that so it's more obvious. But we can add an else if, because as we can see, the inventory doesn't only have string values. So we also want to print the position. All right, so we add an else if the type of the item equals table. Why table? Well, very simply, because this is a table. We call it dictionaries, we call them arrays, but at the end of the day, the type is table. Okay, then what we want to do is something different. We want to do local name dot quantity, and we get the first value of the item and then the second value of the item. So in this case, our item will be a table, and in this case, it has two values, potion and the quantity of the potions. Okay, so we access them into local variables, and this is how you can define multiple local variables in a single line. And this is how you can store them. So item 1 will be stored to name. Item 2 is going to store into quantity, okay? So you can go ahead and do a print. I'm just going to autocomplete this with the AI of Roblox. Doesn't really matter. We're just printing stuff over here. And let's run the code. So we see here that sword costs $10. We see that the potion of quantity 3 costs $60. Boom. Really, really lovely. So what you can do here is try to extend the script by adding new items, update quantities, and play around with everything. You could also change this prices table to use like strings instead, like that, for example, and play around with everything. So yeah, we made a very simple inventory system. We made a prices system, and we worked on top of two different table structures to see the value of each item by working with both of these together. So right now we finished this tutorial series. Stay around, press the subscribe button, because in the next one, guys, we're gonna create a small parkour game where we're going to collect coins and speedrun stuff. It's gonna be very interesting. It's gonna be very, very nice. Thank you so much for watching. Welcome to the final tutorial that will teach you how to create a simple OB game. That is a parkour game inside Roblox Studio. We're going to pretty much use everything we learned up until now and create a small, super fun game so we can train ourselves into game creation and learn everything we did up till now, like a revision. Let's begin. So the first thing is we need a base plate, like we have here. So we need a spawn location and a base plate. This is just a typical Roblox project. So after we did that, what we want to do is we want to create a new model inside the workspace. And what we're going to do is we're going to rename this into main game. Inside this model, we're going to place all the 3D assets for our game. So press the plus button and add 4 folders. As we've said, folders are important to organize our directories. The first folder is going to be named coins, because in our map we will have coins to collect. The second one is gates, because we will have gates that act as placeholders and as shields from players progressing when they shouldn't progress in the game. And finally, we will have stages, which is different levels. The fourth actual folder is buttons. We're going to have buttons that when touched by the player activate specific properties. So the first thing is to organize our game. Now we move to the second thing, where we begin by creating the buttons, the gates, and the stages. And that's very simple to do. Go inside buttons and create a new part. Let's say that this is the button, all right? We see it over here. We can move it around. So what we're going to do is we're going to add this button. We're going to scale it. You can scale it as you like. Doesn't really matter for me, but I'm going to do it like that. I'm going to make it also a little bit thinner, like this. And I'm going to put a color of red to this button, all right? So this is our first button. I'm going to name it Stage 1, because this is the button that will activate Stage 1. And we want to make sure that this button is anchored, so when we touch it, it doesn't move. All right, so we created the first button. The next thing we want to do is to create a gate. So we go into gates and we create a part again. This part, give me a second. Okay, so this part we want to make sure. Okay, so first of all, let me select the part. This part we want to make sure that it's very, very tall. All right, so we're going to use the scale tool again to change how big it is. So I'm going to make it like that, make it tall, and make it just a little thinner. All right, so this is our gate. The gate is going to be color, I don't know, let's see, maybe some kind of dark blue. I like that. And now we need to make the platform. So essentially we're going to make stage 1. So inside stages, we're going to create a new model. Again, as we've said, models uniformly hold different parts that have the same attributes, and inside here we're going to place one part here. So let's scale this like that, and what I'm going to do is I'm going to move this gate out of the way for now. And what we're going to do now is we're going to click Ctrl D to duplicate this part. I'm just going to place this a little upper like that. Ctrl D again, and do it like that. So you get the memo. Then I'm going to click Shift and left click on top of all of these, duplicate all of them, move them like this. All right, so we're creating essentially the parkour map. Looks kind of nice, to be honest with you. And boom. Okay, so this is like our first level of parkour. All right, so in this case, just to finish up the first stage, I'm just going to duplicate this. And this is like the platform where the player will sit. So what I'm going to do for this is I'm going to make it just a little bit bigger like that. And then we're going to go and take the gate from there and bring it over here. So the gate is protecting the logic of the map, so the player cannot move forward. And we need to make it just a little bit bigger to the side. So yep, the player cannot pass the gate. Also, make sure to check that everything is anchored, so players cannot like hit these things. And okay, we set the anchored setting. All right, so we got this part ready. This is like our 2D map, our 3D map actually. So let's check it out. Let's see if everything works correctly. Let's see if we can parkour. I'm a little bit of a noob in parkour. Okay, so let's try this. Okay, and boom. Okay, so we cannot pass, and we got our little parkour going on over here. All right, looks good. We can continue to scripting. All right, so let's begin with some scripting now. So what we're going to do is we are going to program the button to detect when it's touched and activate the gate. So for us to do this, we go to server script service and create a new script that we're going to call main script. Okay, let's delete this and let's start coding. So we're going to access the main game storytelling variable that is local, so workspace, and we want to access the main game model. We want to extract the gates from the local game model. So main game, get children, and we filter by gates folder. That's the first one. And then we want to do local buttons equals main game, get children, and we're going to filter by buttons folder. So we're going to get all of the elements stored inside the gates and inside the buttons. All right, so then we want to do a for loop. Wait a minute, what do you mean, Iro? What for loop? Okay, so what we're going to do is we're going to do for button in pairs. And here what we are going to do is, and okay, a small correction, I did a mistake here. What we want to do is we won't wait for the childs to load, that is the folders here. And then here we want to get the children of the buttons folder. So get children, and then we want to do, so we actually do the for loop. So if button is app, so this checks the type of the button that it found inside the folders. So if it is a base part, then what we want to do is we want to check that when the button is touched, we want to add an anonymous function that takes as input the other, which is essentially a part, and usually it's a player. We want to check if this other part has a humanoid inside it. As we have said in the previous videos, our characters, when we play, have a humanoid body that we can filter to understand whether this is a player or not. So we're going to find first child, okay? So find first child, not of class, just for child. And what we're going to search for is humanoid, all right? That's what we're doing. We're checking whether the parts parent includes a humanoid inside it. If it does, then it's a real player that is touching the button. And we really need to do this because when the player touches the button, we want to start a timer. So if indeed a humanoid doesn't exist, we want to return. We essentially want to stop the loop, okay? And also what we're going to do, just for safety here, we're going to add a touched button that will be able to find an attribute that we will specify as touched. This is going to be a Boolean instance. So we make sure that we don't have duplicates or whatever. So we're going to change this clause instead of return and all of that. We're going to filter with humanoid and touched. So if both of these cases are true, then what we want to do is we want to activate a button. Okay, we're going to write a different function for that, but let's write it here and we're going to define it above. So the button here is actually touched. Okay, so we're going to take this and define a local function, activate button here. So let's see what we're going to write here. So it works exactly as we want. So it will take button as input and touched as input. And what it's going to do is very, very simple. It's going to set the value of touched equals to true because the button gets activated. And also we're going to take the duration where we're going to have to search for the find first child of the button equals the duration. So we're going to do these changes very soon. We're going to add some attributes here. Bear with me, don't worry. And what we want to do here is for the activation to wait for an amount of time. So it's gonna be duration.value. So for the duration specified inside the button, that is, for example, stage 1, we're going to wait for this task for a while. After this time passes, then touched will become false again. All right? So that's how we mess up with the activation of the button. So let's make that as well. So we go here to stage 1 button. And what we're going to do is we're going to say bool value. We are going to rename this to touched. So it can be referenced here. Okay, super simple. And we're going to add also an int value that is going to be the duration. So for how much and for how long this button is going to be activated. I'm gonna set the duration here into the value of 10 and touched will be in the value of false. So by default, the button will not be touched and its duration will be like 10 seconds. You know, actually, I'm going to make it 15 seconds because I'm a little bit noob with, parkour. And here, the importance is that we want to check that humanoid exists, touched exists, and we need another check. We need to see that the value of checked or of touched is equals to false. Because when the button is activated, we don't want to activate it again, okay? So it needs to be deactivated to be activated again, all right? So this is just one more thing that we want to do, just to make sure that the logic of the game is indeed correct. So now what we want to do is, okay, we got the duration, but now we want to reference the gate. So what we want to do is we want to take the gate and save it in find first child of gates. All right, so we will go into the gates folder and find the first child. And actually, to do this more correctly, we want to change the name of the gates part to be stage 1, so we can easily filter this out through the button.name. So each button, it will have stage 1, stage 2, stage 3. And the same happens with the gates. So we can easily have consistency over what button corresponds to which gate just by using the name. So that's also a very powerful technique. If you have consistency and you enforce it everywhere, this is going to make your code a lot more easier to read, and you can just change, the names here for new buttons and it will still work. This script will be general enough. So we are not done yet. Before we do everything, we need to check that the gate actually exists. So we need to make sure that the gate goes into transparency equals to 0.1. So the gate will become transparent. And also we want to make sure that the gate cannot collide. All right. So when the gate is found and the button is activated, this will be like that. And then after the task wait, we want to make sure that the gate goes back to the original transparency and can be collided. What means to be collided? It means that you cannot pass through the gate because the character will hit it. While when can collide is false, the property collide is false, then you can pass through it. All right, simple as that. So just a couple of changes before we run the script and test it out. As we can see here, I changed the transparency to 0.9 and then to 0 because it was exactly the inverse of what I specified. So let's try the game. Let's see if it works. So here we can see the button. So when we hit it, we need to start running. We see that this is transparent and we can potentially pass through it if I stop failing the parkour, which I fail all the time. Oh my god, I'm such a bad Roblox parkour player. And boom, I was not fast enough to pass through the gate. So I need to go back to the beginning and play the game again. Oh my god, all right, let's do it. Boom, we hit the button. It's transparent, or at least transparent enough. And boom, we passed through. So we made it. We made a replicated stage. And now we want to go ahead and add coins to the game. Let's go ahead back into our 3D game. Just stop playing the game, guys. I know you love it, but... So we're going to go into the workspace and we're going to add a coin. So you can do a coin, I don't know, probably like add a part. So add a part, but make sure that the part is a sphere. All right, so that looks more like a coin. Okay, I mean, it's a circle. It's a sphere, actually, not a circle. So we could add it like here, put it up a little bit, center it just a little bit. You're good to go here. So what we're going to do with this sphere is we're going to make it like some super yellow thing. We're going to make it reflect a little bit and make it transparent a little bit, just a little bit. So here, what we're going to do is we could change each kind of material. And the good material for that is like neon. So you could use like neon here. You want to make sure that it's anchored, but is not collidable. So remove the can collide option. Also make sure to like give it a good name. For example, part is not gonna cut it, so call it coin. All right. And what we're going to do right now is we're going to go ahead into our server script service and add a new script for the player stats. This is something we already have created in previous tutorial. So let's go ahead and write player stats and let's begin scripting. So we're going to go into game.players.playerAdded, player added. When the player connects, we're gonna do the usual tricks of running an anonymous function. All right, that is going to take as parameter the player. So what we're going to do here is we're going to make a leader stats variable, which is going to be a new instance folder. And we're going to name this leader stats. The parent will be the player, and we're going to give it, coins in value. Pretty much the AI inside Roblox will pre-fill it for you. It's a very famous, well-known script, so you don't have to worry about that. Now, don't forget to move the coin inside the coins folder, all right? Super important to do so. So let's clean up the code just a little bit and let's keep forward. So we got to make sure that we connect the coin values to the actual game and to the actual 3D coin. Otherwise, this will not matter. You just have initialized your leader stats. So to do that, we want to go into local main game and we want to access the main game folder. Again, AI is super useful for this kind of things, super understands what you want to do. So we're going to access the coins folder. So we go to main game and we're going to do the typical wait for child coins. All right, so we access that. And also in this case, maybe I would suggest for you, instead of just going ahead and accessing the game, that you do wait for child as well, because this is like a model of the game and it might not be found and you want to make sure that you wait for it, okay? Just make sure to wait for it. Don't go heads first, accessing it. That's like a safety measure. So what we're going to do is we're going to search the coin folder in this case. So for _coin in pairs, and we're going to do coins get children. So what we want to do is we want to do a loop, all right? And what we want to do is we want to make sure that when a coin is touched, we want to do a connection. So what is going to happen here is that when each of the coins in the coins is touched, an anonymous function is assigned. The anonymous function is going to do some very specific things. Let's see it exactly. First of all, each coin will have a Boolean value instance inside it. We're going to again say that this Boolean value is touched, by default false. So instead of what AI has written here, just go ahead and delete it. It's not correct. what you're going to do is you do the typical humanoid check that we did exactly with the button, all right? So let's go ahead and do that. So again, we search what the other part's parent is and if it has a humanoid inside it, good to go. So when it's a humanoid, we want to go to local player and we access the player again by game players and we want to get the player character. I mean, AI could have solved it, but I don't know why it does it like that. Get player from character. And here we want, if I'm not mistaken, other.name. I'm not exactly sure about it. Let me check here. So it uses a model. So here we want to make sure that the other parent is actually accessed. So here the character of the player is essentially the parent of other, which is a part inside the model. And then we want to make sure that we check whether the coin has an attribute touched and what the value of touched is actually is. So that's what we're doing with touched. So again, we do the typical if humanoid and player and touched and value of touched is false. And we need to zoom out a little bit because this is unworkable and I'm sorry for that, but Roblox Studio is really fucked up at this point. And it makes me really angry when we have this kind of super long checks. And usually what I try to do is break them like that. So it's easier to see without having to go on the right hand side. But you know, Lua is very verbose. You need to write a lot of stuff and it's really boring. So what we're going to do here is we're going to make the value, equals to true. All right. I'm just going to give one more space here so we don't mess up the code. So we're going to go to player.leaderstats.coins.value. And what we're going to do is player.leaderstats.coins.value plus 1. And you could do this with another way that is super interesting. Let me show you. You can do plus equals to 1. So it's going to append, it's going to increase this value by 1. So it's plus equals 1. And to make this even more interesting and, you know what, some learnings that we have from previous tutorials, we're going to make the reward to be a random amount of coins. So math plus random 1 to 5. And instead we're going to increase this by this amount, a random amount from 1 to 5. We don't know which amount exactly. So when this happens, we want to make sure that the coin that was touched essentially gets its transparency equals to 0. All right. So essentially the coin is not going to be transparent anymore. And I did the exact same mistake as previously. Actually, no, I think I did correctly. Transparency equals to 1. So it hides the coin after the coin is touched. And then it increases the value of coins in the leader stats folder by a random amount, which is exactly what we want to do. Also, I made a mistake here. We don't want our int value to be of name cash. We want it to be of name coins. So here you want to do coins, okay? Just make sure to do this change. So I run the game and do a small test and we see here that we got a mistake. So game workspace, you cannot use dot here. You need to do this kind of thing to wait for the child, which is the main game child. And let's see if it works. Okay, we pass. Okay, with the mistake here, boom, we took the coin, we took 5 points and we passed. So we made the game logic actually work end to end. We just did it. It's absolutely amazing. So now we got our first stage done. We have a coin collection system, we got a leaderboard, we got the gates working, we got a nice parkour game that we can use as a reference and as our first game. And you could very much easily expand this to multiple stages by going ahead in the workspace and, for example, duplicating the stage 1. So you could do Control D, rename it to stage 2, and you could go stop the game for sure first before you do any change. So do Control D, rename to stage 2, and then what you want to do to make this work is select the stage 2 and you could go ahead and do something like that. So put it upwards and the player can continue from this point forward. Look at this, works beautifully. And of course, you can create a stage 2 gate that again works. You could add like this button that you are going to call stage 2. So just make sure to change the stages, move the coins around so you could control the coins and add the new coins here. Doesn't matter. The behavior of the script is general. And this is how you build a simple obby game with rewards that you can collect as you progress in the game. You have obstacles, you have timers, you have random events that give you bonuses. And yeah, make sure to play around with it. And, go ahead and make a more complicated game. Make a more complicated game. In any case, everything you need and some more works are inside the Roblox Bible down below in the description. So yeah, all of the scripts are also here, so you can check them out if you're interested. And I wish you the very best for joining this kind of tutorial and this kind of course. Hopefully you learned something new. Maybe I wasn't the best instructor in the world, but at least I tried to give you the basic concepts in a new language, in a new format, try to explain what matters by going in as much detail as needed without being boring.